Hello everyone and welcome to week number 4 of the Intense Crash Course in Objective-C class. I'll be your lead instructor tonight, Mr. Jason Busby. That's right, that's right. Make sure you fasten your seat belts. It's going to be a fun ride. Also joining us is co-pilot, Mr. Nelson LeKay. Nelson!
Hey.
Hey. All right, so I do apologize once again to those of you that are joining us tonight. We're doing this class as a makeup class for the one that got canceled the week prior to Christmas. And unfortunately, this class fell right at the end of the Introduction to Android class, week 2, which made things interesting, getting things shuffled around so that we could get it up and going. So we are running just a little bit off schedule at the moment. Not a worry. You guys know I don't think I've successfully managed to give you only a 4-hour class once throughout this entire course. So, oh well. And I doubt tonight will be too. Though I'm going to have to try to be a little bit better with time tonight because Thomas Dodd, who some of you guys know has been staying with us for a while, it will be arriving in Nashville at like 11 something tonight. He needs to be picked up, and it would really like stink if we just forgot about him. So Jonathan and Rowdy, you guys got to remind me to make sure somebody goes to pick him up, and we don't forget what's going on because that'd be horrible. So we are going to be adding a 5th week to this course. He needs to be picked up tonight. Somebody needs to leave around 10:30ish probably. So that's 10:30 our time. Actually. Thank you for asking, sir. So anyways, the 5th week, we are going to be introducing concepts that were not originally planned for this class, but I would like to get them in before we get into the iPhone development class, so that once we're into the iPhone development class, if we want to make use of, and we will be, of course, things like delegates, we will have already covered them in the Intense Crash course. And I can tell students that will be joining us for the first time over in that course that if they have no clue what we're talking about, then they can head back over to this course and watch. And for all of you that are joining us tonight, and those of you that are listening to this later, I encourage you to come and hang out with me. I believe we're going to be doing it next Thursday as well. I know Nelson's going to be bummed about that. But that's okay. It's all good. We will make the drawing workshop probably on a Saturday or something. So anyways, I think this is more important than just a workshop for if anybody needs help with, drawing. Because this is like hardcore content.
This is like hardcore. No.
Yeah. So tonight we're going to be starting things off with a quick review of a couple of the things we looked at in the last time we met. From there, we're going to be moving forward into a closer look at object-oriented programming in Objective-C tonight. We're going to be looking at proper syntax and all for defining classes, instantiating classes. We're going to be looking at defining methods, in both instance and class methods. We'll talk about the message anatomy. We'll talk about nesting messages. We'll talk about self. We'll talk about class initializers. We'll be talking about properties. And again, we're still going old school as far as memory management goes. Yes, Mr. Lewis, we will be talking about synthesize, because if you're going to take advantage of the property compiler directive, then you definitely want to take advantage of synthesize. At the same time, there will be times you may want to use the property compiler directive and not use synthesize. So we'll be looking at all of that as well. And also the different attributes that you can use when defining properties and telling the compiler how to go about synthesizing, how those getter and setters are going to work if you need to work in or have them work in very specific ways. We're going to be talking about memory management. We're going to be looking at some very simple memory leak examples. And then automatic reference counting. That's another interesting one, Jonathan. We'll talk a little bit about that tonight. I'm going to put more of that into next week because the interesting thing about automatic reference counting is it's not garbage collection. First thing we have is people that immediately think, oh, hey, we now have garbage collection. No, it's not like that. It is, it's a pre-compiler or a compiler thing, basically, where the compiler is going to go in there and analyze your code, and it's going to figure out where the retains and releases need to be set up, and you're going to give hints to the compiler as to how different data members need to be handled. And the interesting thing is, I can give you the very simple set of rules for it and say that's it, but there's some more advanced things that we kind of need to get into that I think would be helpful in making it a little bit more clear to those of you, especially those of you that are really, really new to programming altogether. So yeah, and it is far more efficient than the garbage collector, without a doubt. So anyways, let's see. Also with that, I have thrown in the start of us using data collections tonight. That was something that was not going to be covered at all, but we will be looking at NSArray and NSMutableString. And then next week I will be adding in dictionaries as well. Again, just trying to get you guys armed with some different things that we can take advantage of when we move over into the iPhone class. So, Nelson, are you with me?
Mm-hmm.
So last week, well, I'm going to say last week referring to the week before, but the last time we met, you gave your introduction to object-oriented programming. And then yours was kind of technical, so then I jumped in with a very simplistic approach. And then we went from there into an example of putting together our first OOP application. It was a simple OOP Hello World. But now what I'd like to do is back up, if you don't mind, and jump back over to you and let you talk about it one more time in a review. Now you can be a little bit more techie with what we described.
Yeah, let me go ahead and swap my tablet.
And the big thing that I would like for you to add into tonight's discussion with this review, because it's actually going to be something we'll be focusing on, is, again, make mention of inheritance and polymorphism. And yes, Jonathan, I love the .NET garbage collector myself. So is it good for me to flip it on over to you, Nelson?
Yep.
Okay, all right, let's go ahead and do that.
And of course my keyboard stopped working because it's Mac. Show my screen. And I don't know which screen you're looking at right now.
Rainbow Dash.
Okay.
Oh, well, thank you very much, Terry. That's awesome. Glad you liked it.
Sorry, when I said I was ready, I actually didn't mean that I was actually ready.
Oh, I see.
You should be able to tell a difference. Come on. Okay, let's see here. I told it to open a new file, and it seems like it opened it up behind the GoToWebinar panel. Here we go. Alrighty. And one last thing is I need to constrain it to my display. Okay, so I am finally good to go.
Okay.
Actually,
as you change your background color, I'm going to want you to start out by just talking about the concept of object-oriented programming. Just, you know,
yeah.
The whole programming paradigm. Why do we even have it?
Because we said so.
And then one last thing, I just need to get BuzzNet visible again. There we go. I probably should have asked you to pause the video. Okay, so object-oriented programming is really at the base. As far as why it was invented, a long time ago, we had procedural programming. We still do have procedural programming to an extent, and a lot of the stuff that we learn about in procedural programming is very easy to merge over into object-oriented programming. So what is procedural programming? Well, procedural programming is the composition of procedures. So we have procedures such as, this should look familiar, main, and we have other procedures maybe like show menu. And maybe show menu depends on a procedure like printf. And then maybe main depends on show menu, but main also depends on something like print output. That does some sort of computation. Actually, that's a horrible name for a method function that does computation, but you get my point. We have procedures or functions. So that's how we used to program pretty much everything, and that's how we've been programming in this class for, well, basically since the beginning of it. We talked about functions, we talked about the main function, we talked about creating our own functions. But functions have limitations because functions typically do things or start to grow in complexity where you find that they start depending not only on other behavior but also on other state. For example, if we had a program that we're writing that that has a person and it has a person's name, we might start off with something like, I know Jason's going to shoot me for this, but we might have a string name, a character pointer name, and we want a program to kind of allow us to modify and read and work on this name. So we might have functions. So here's a global variable. We might have functions called something like void, or why did I make that? Whoa, that's a big eraser. So we might have something like a global variable name. But then we also might have functions like getName. What is getName responsible for? Well, it prompts the user for a name and returns it. Then we might have another function called, how about modifyName? And then we might have a function called printName. So here's a decent little procedural design for our program where we have our state up here, this character array name, and then we have different methods, different behaviors that act on this global state. The whole point of object-oriented programming is to take this whole idea of a combination of related state and related behavior and basically turn it into an object. Now, typically what you would see here is in a procedural program, you would have a lot of these global variables, and you would have a lot of these functions that modified those global variables, and a program would become very complex very quickly because there wouldn't be any clear distinction as to which functions own those global variables and how they behave. You can mitigate that issue slightly by passing in parameters. So let's see what it would look like if instead we design this where we pass in parameters around. So we might have a function called getName that returns a string. So getName. This function is a lot better now. And then we might have a void printName. This function, which accepts a string, is also a lot better now. Now, before we can move on to explaining how object orientation actually fixes this problem, does everybody understand why this procedural design is actually preferable to this procedural design? Is everybody kind of seeing why that might be a better design? As far as we no longer have this global state, instead we're passing the state around. Well, let me ask you a simple question. In this design, how would we manage multiple names? If we have this string global name that's global to the entire program, and we have these functions that depend on this global state, how do we manage multiple names? What if we wanted another user or do multiple names? Oh, Scion. Anyway.
Well, he's right.
Yeah, but still. MMODES says like name 1, name 2, name 3. Yeah, you could do that, but it would be very ugly. So this is a better procedural design. And the reason it's a better procedural design is now we can have as many names as we want and as many people as we want, and the state no longer is global. Where's the state in this design? Can anybody tell me where the state is? Right, well, it's internal, but there's 2 points where the state is now. In this case, the state is up here. In this case, the state is both a return and a parameter. In one case, it's a return, and in one case, it's a parameter. So that's great. We now have our state kind of encapsulated by these two functions, and it's no longer leaking into the global scope. But we have a problem. What if we wanted to extend our program so that our name is not just a single name, a single string, but it's two strings? A character array called first name and a character array called last name. How do we expand our better procedural design to now handle a name as if it were two distinct objects? Well, the answer is object-oriented programming.
Not blue screen of death.
That is awesome. Oh, Zion.
But yeah, I mean, we create a class. We create a class that composites. Well, we don't create a class. I want to back up. We don't actually create classes. Well, we do, but that's not the goal. The goal is not to create classes. The goal is to create objects.
Because that's what we're talking about, is objects.
Right.
Yay!
But a class is a feature of Objective-C and many other programming languages that make it very easy to create new objects. And it's a two-step process. We create the object definition. And the object definition basically takes what would normally be up here and puts it into code down here. But that's just a definition. This is the class. It doesn't actually do anything on its own. It basically just defines what objects instantiated from this class, how they'll perform, and what they'll do. So then we need to actually instantiate them. And we instantiate them with the... Jason, help me.
Instantiate them with... Oh, you're talking about an Objective-C?
Yeah, is it the Alloc operator?
I'll just make it easy for you with new.
Oh, it's new. Okay. So we instantiate them with the new operator. And that turns it into an object. And this happens at runtime. This happens at compile time. Simply creating a class is not going to alter the behavior of a program whatsoever. It's only when you use the new operator that that class gets turned into an object, where it's basically, you can think of the class just like a prototype or a blueprint for the objects that are going to come out of it. And the class, like I said before, it composites two things, behavior and state. So, for example, what we have up here is a poor example of, this is bad code. It's bad code because this behavior and state, it's not organized, it's not encapsulated, and you're also relying on global state, which could very easily step on the toes of your other functions that you might want to use and reduce the usability or extensibility of your program. Object-oriented programming in any form, whether that form be in Objective-C or even C itself, object-oriented programming is a paradigm. It's a way of approaching a problem. It's a way of treating things as if they were objects. And again, an object is state and behavior. That's not how you spell behavior, but I don't care. So that's what an object is, state and behavior. And different languages give you different ways of making objects. Objective-C gives you classes. C on its own does not give you classes, but you can still kind of mimic it abusing other aspects of C to kind of give you the feel. But object-oriented programming, I just want to point this out to a lot of people who don't typically understand this. They look at object-oriented programming as a thing that you either know or you don't know. So they look at object-oriented programming like a programming feature. So a lot of people see OOP and they see, oh, well, I just either don't know that or I do know that. Just like you might say, I either don't know how to use printf or I do know how to use printf. With printf, that's true. You either don't know what it does or you do know what it does, and if you know what it does, you can use it. Object-oriented programming is not like that. Object-oriented programming isn't a concept you just learn. It's a paradigm that you have to kind of get a feel for and an understanding for. Where you delineate what behavior and what state goes into each object is something that's going to come with time. Now, you can always start off with what would make sense in the real world. So if you have a person, if you want to make a person object, you might start creating a person class, give them a name and an age and a hair color, whatever other thing your program wants to track. Now, I do want to just point out one word real fast before I get into the other stuff Jason wanted me to talk about as far as polymorphism. But there's one word that I use a lot, and you're going to hear me use a lot in a lot of other classes too, and that is a model. And what exactly is the definition of a model?
She's got to be hot, 6 foot, thin. Oh, sorry.
Hey, she can be short. I'm just kidding.
A model is an approximation. So, for example, you might have a building, a big building with a bunch of windows that don't look like windows, and I don't know, that looks horrible. But anyway, you might have a huge building, and then you might have a model of that building. And the model is an approximation. That's all it is. And when you create a model, you need to decide what it is that's important to you about the thing that you're trying to model or approximate. Now, in this case, if I create a model building, I'm typically not worried about the size, although I am worried about the scale. I want the scale to be correct, but I don't want the size to be correct. I don't care about that. That's something I don't care about, because that would be a very useless model if the size was the same. But then you have to decide, why am I creating this model in the first place? What am I trying to represent? Well, maybe we're working on the design of the building. So in this case, you would do color and texture.
I just approved it. Continue.
Okay, so in this case, your little model building would have a color and texture, because the reason you're creating this model in the first place is to do the design of it. But what if that's not why you're doing it? What if you're trying to model it to identify its structural integrity? Well, in that case, it might be more important for you to model its materials and its internal structure. My point is that a model will never, ever, ever be the real thing, ever. It'll always be a select few attributes that are useful for your understanding of a problem, for you understanding the solution of a problem. This is a word that I'm going to be using a lot, and it's important you fully understand what I mean when I say model. In object-oriented programming, a model is the exact same thing. So, for example, we might have a person in real life. But let's say I'm writing a program, an online discussion board. Now, a real-life person has a lot of stuff in it. I mean, it has just everything, really. But we only care about a few of those attributes in order to model a person. And the attributes that we care about are dependent on our problem. What are we trying to solve? Well, we want a discussion board. So what bits of a real-life person are we going to model? Well, we want his name. How about his age? That might be important. And maybe a picture of him for his avatar. So what I've essentially done is I've taken a real-life object. I've looked at my problem. I've identified my problem. and then I've turned that into an approximation. And that's all object-oriented programming is. You have a real life, you have a real problem that you're trying to solve, you look at the real world, you pick and choose the things that you want to model, and then you model those things using the tools that your language gives you. In this case, this model in Objective-C gets turned into, what does it get turned into, anyone?
Object.
An object. And how do we create objects in Objective-C? What do we, in Objective-C, now this isn't true for all languages, but in Objective-C, what do we need before we get an object?
Before we can even instantiate it.
Not the specific file. Well, close. I'm missing like one word. Description of the model, good. Prototype, declaration, you guys are getting close, but there's a specific word that's used, not a variable. There we go.
Yeah, that's what I wanted to say.
Class.
Yep.
Now, people, it's good that you guys are obviously paying attention because you guys basically gave a bunch of synonyms of the word I wanted, but the actual word that I wanted was a class. And what do we do with the class at runtime? We new it up. Or instantiate. What happens when we new up or instantiate a class? We get an object. So this is the workflow of approaching or creating a program using object-oriented principles. We start with the problem. We identify the problem. We use our identification of the problem to pull real-life analogs into our model. Then, once we have our model figured out, we turn our model concept into a class. Now, this is where the programming begins. This is the programming. This is the design. Two completely different separate states. And keep in mind that it's not, you typically will not design the entirety of your program and then program it. You will commonly go back and forth between these two steps as your program gets developed.
And I do want to throw in there just real quick, since I know Jonathan is a bit more of an advanced user that's following along in this extremely beginner class, I will so fail you if you don't fix that new person line that you put in at 650. Continue, Nelson. I'm sorry, that made my eye twitch.
And I'm looking at it.
You don't have to have Xcode. I tried drilling it into your head with all but a sledgehammer the last time. Thank you very much, Mr. Norton. That's very good. Carries all over it. If you're going to use Alloc and Init, you're making an object on the heap, my friend. You better have a pointer.
Don't be making his eye twitch.
My code is magic. Okay, back to you, Nelson. So far, so good. This is great stuff because this is going to be important a little bit later on.
Okay, so I'm about to move on into something else, talking about some of the sort of things we can do and the sort of the patterns we can do in object-oriented programming, such as encapsulation and polymorphism. But are there any questions about what I have up on the screen? Is everybody following along? Is anybody getting a better feel for what object-oriented programming actually is and why you'd want to use it?
Jonathan keeps saying, so the model is the class, or the model is .h and the class is .c?
No, the model is the class. The model is the conceptual idea of the class. A class is a programming representation of a model. A model is an abstract concept that lives inside of your head. A class is how you describe that abstract concept into a programming language. However, I very often do refer to classes as models. So keep that in mind. There are many different kinds of models depending on what you're doing. There are persistence models, domain models, view models, and they all have different purposes. And I use that language very frequently. But obviously that's beyond the scope. So it wouldn't be considered a prototype. No, I wouldn't. I wouldn't use the word prototype to describe a model. I would use the word prototype to describe a class. Okay, so that's just kind of a basic overview of what we can do with object-oriented programming and why we might use it and where it kind of came from. But there are some specific things within object-oriented programming that have names. People have already been doing object-oriented programming for 30-some odd years now. And over the last 10 years, it's been accepted into, it's pretty much been accepted in its entirety into the mainstream programming methodology. And there are a few different things that are so common within object-oriented programming that specific names have been used to describe them. And that's encapsulation, inheritance, and polymorphism. And polymorphism, I promise you, is less scary than it sounds.
And one other thing you'll often hear paired with these is also abstraction.
Sure. Okay, these are kind of the things that you will hear in a lot of language of object-oriented programming. A lot of people make the mistake of every single object-oriented programming book. I've never found an object-oriented book or explanation that has actually described object-oriented programming in a way that I have come in a way that I actually now understand it as after working in object-oriented environments for so long. And I find that frustrating. Commonly, people will say that object-oriented programming is the combination of these three things. But that's not true. Object orientation, all object orientation is the use of objects. These four things are ways that are common ways that we can use objects in order to accomplish goals or just to accomplish goals. And what are the goals that we're looking for in our code? Well, every code has a variety of constraints or features. I like to consider these things features. Every program has features. And people think of features as, oh, it has a search bar, or it has a menu item, or it has a print function, and all that fun stuff. But the fact is, there are other features within that people often don't realize are actually features. We have things like performance. We have things like extensibility. We have things like memory consumption, which could technically fall under performance, but I'm considering here performance to be how fast your program responds and memory consumption to be how much memory it takes up. We have maintainability. We have stability. And we have readability.
What about extensibility? Oh,
right there.
It just wasn't grouped with all the other abilities.
I know, so I ignored it. Continue.
But these are all features. And like all features, they can be invested in, or they can be ignored, or they can be weighted. And these features must be weighted or ignored or implemented depending on what it is you're trying to accomplish. Typically, everybody says, oh, well, it has to have fast performance, it has to not consume any memory, it has to be extensible, it has to be maintainable, it has to be stable, it has to be readable. But I could very, very easily argue that the only thing that really matters here in this list, as in it must, is stability. Everything else, you're going to have to make a conscious decision to invest in. And that conscious decision should always be led by actual use cases and facts instead of this would be nice to have. performance is one of the big ones. Everybody's like, oh, well, how fast does my performance go? My performance is so important, you know, how many milliseconds do I save by doing it this way or that way? That doesn't matter. Fast enough is all you need. Performance should always be fast enough, and it doesn't need to be faster. Memory consumption, same thing. Obviously, your program during normal use shouldn't consume a lot of memory, but you know what? I don't care that Photoshop uses a bunch of memory. I don't care if Visual Studio uses a bunch of memory. Those are programs that I invest myself in and use a lot, and when I'm using them, I'm not typically doing very many other things. But I do care if Chrome takes up a bunch of memory, because I typically have many, many Chrome windows open at the same time. So my point is in saying this is that all of these are features. I'm getting a little bit sidetracked just describing the different features that people don't typically see as features, but they really are. And the ones that we care about in terms of object-oriented programming is object-oriented programming affects all of these things. Object-oriented programming typically has, it pretty much at this point has a neutral effect on performance. It typically has a positive effect on extensibility. It typically has a negative effect on memory consumption. It typically has a positive effect on maintainability and stability and readability. Performance, it could go either way. Some people could argue that object-oriented programming is inherently less performant, but I'm not going to consider that a minus here. So object-oriented programming can provide us with advantages in these features with less work. And if a feature requires less work to implement, then it's more likely you are going to implement that feature. So some of the ways that object-oriented programming actually does help with these features are with use of these 4 kinds of patterns that we'll see quite often. So let's talk about encapsulation. What's encapsulation? Well, if you look at the word itself, you can probably kind of figure it out. Let's say each one of these boxes is data. And here is a global program with everything global. Now, the problem is that our functions, so this is a big problem. Our functions can modify anything it wants. And I'll make this a little bit clear. How do I step back through history again, Jason?
Control-Alt-Z.
Control-Alt-Z?
Oh, hang on. I use
Alt-Command.
Oh, yeah, that's right. You're on the Mac. Okay, good. Yeah, Alt-Command-Z.
Yeah, I know how to do it on PC, but I was...
Usually when you ask me questions, you're actually working on your PC, and I have to translate everything because I'm always on the Mac. So I was just translating. Yes, Command-Alt-Z.
Alrighty. So here's our program that has a lot of global state, and it has functions, and it might have F1, F2, F3, F4, F5. And let's say F5 depends on these bits of data to be consistent and valid. And consistency and validity.
That's a hard one.
Yeah, it is. Wow. Are both attributes of data. Data can either be consistent or inconsistent or valid or invalid. And the consistency or validity of data is dependent on the function. Because what if F5 considers this block to be valid only if it's half filled in, but then F4 reaches in and decides, well, I'm going to fill it all the way in. Now this data is considered invalid for F5, and the next time we tell F5 to do some work, it's not pulling data from data it considers to be invalid. But F4 has no way of knowing if this data is in a valid or invalid state. So what we get here is just a huge mess where we have methods that depend on data, that read in data, functions that read in data and depend on data and change data. And notice how all these lines are going from left to right, but all the validation rules is handled over here. Validation is handled in functions. There's no way to specify validation at the data level, not without OOP. So if all the validation is in here, how can we ensure that access to these blocks of data constitutes a valid operation if we can modify these blocks of data directly? Encapsulation is how we solve that problem. Encapsulation makes our data, which is no longer data, it's now data and behavior. And it turns it into something that looks like this. A big block. So pretend this is an object. So this is an object, OBJ. And it has a bunch of data. However, this data is arbitrated by the behavior. So let me make this diagram a little bit more clear. This is the data, and this is the behavior. So we might have F1, F2, F3, F4, and these functions, they're allowed to play with this data as much as they want, just like in the global program. The difference is that the scope is considerably smaller, and it's a lot easier to make sure that all these functions will modify this data consistently. And now, if, let's say, the main function of our entire program, everybody knows what main is, let's say main wants to change this data right here. How does main access this data? Well, the answer is this data is encapsulated within an object, meaning the object is now the arbiter of what happens to this data, and main would have to go through a function on the object in order to change the data. And that function could, in theory, even say, nope.
Is that what you wrote?
It wrote throw.
Oh, okay. I didn't know if you wrote crow or schmro, or I didn't know what that was.
Now, I don't think we've talked about exceptions yet. But what I'm saying here is that this function can say no. It can say, no, main, you may not alter my data this way. That makes it inconsistent and invalid. Encapsulation significantly impacts pretty much all of these. Significantly impacts our extensibility, because when we extend our program, we have fewer things that we have to worry about as far as who modifies what. We know that this data is owned by X, and we know, and we can read X in one page. Your classes should be short. They shouldn't be very big. You should be able to read a class pretty quickly. And you should be able to know immediately the only people who have access to this data. Encapsulation also helps, obviously, with maintainability and readability, obviously, because maintainability and readability are greatly increased by just being able to read the program and alter it. That's pretty much it. So extensibility, maintainability, readability are very similar, and whenever one of those gets affected, the other two get affected. Whenever you increase readability, you increase your maintainability and extensibility. Or not as much extensibility, I suppose, but still. So how's everybody feeling about encapsulation? How are you feeling, Nina?
I'm feeling encapsulated. I feel it's great. Yay.
It's something, according to MMOdest. I think, is that like...
I don't know.
I feel that people are maybe understanding it. It's a container. Yeah, it's a gatekeeper. It's encapsulation. It encapsulates things. It says no, you cannot do this to me if this condition isn't met. to other people, as opposed to them just reaching right into you and modifying your data. Okay, so inheritance. I have a very fun relationship with inheritance. People who have seen my previous C# videos should know my
dislike
my
for?
whole spiel on it. You what?
Your dislike for?
Yeah, my dislike for inheritance. Inheritance in theory is a very, very interesting thing, and in practice can be used to incredible effect. But people overdo it too often. Inheritance is all about taking an object that behaves in one way and tacking on additional behavior to it. So we might see an example of inheritance where we have a see, it's something that I don't use very often. It's a feature of most programming languages I just don't find myself wanting to ever touch. Blah, blah, blah. Let's say that we have an object or a class that's capable of, I don't know, iterating the file system.
Okay.
See, I wouldn't even do this though. That's dumb.
You could use a very real world example. NSObject is the root class in which all of our other Objective-C classes that we will define are going to extend from it, because there's some very important stuff that every single, just like with C#, that every single object needs to have.
Okay, so what Jason was talking about is we have a NSObject class, and we inherit from it. So we have our own class one. I don't know why that's sideways. We have our own class 1 and maybe a class 2, and they both inherit from NSObject. And I believe that's the proper UML for it.
You got the arrow right, but generally they're drawn up underneath. But good enough, good enough.
Okay, so we have class 1 and class 2, and they both inherit from NSObject. What does that mean? Well, that means all of the state and behavior of NSObject gets packaged up and basically put on both the objects or both the classes that inherit from it. And that's it. Inheritance is just it's a way to have a class that does a particular thing or has a specific feature to it, and then create a derivative class that carries with it all of the state and behavior of the base class. And so in this case, this is the base class that I'll sometimes refer to as the parent class. These are the derived classes, sometimes referred to as the children. And inheritance hierarchies can be as deeply, unfortunately, inheritance hierarchies can be as deeply nested as you wish them to be. So for example, I can have a class 3, and class 3 can inherit from class 1. So what does that make this? Well, in this case, class 1 is now both a derived class and a base class. But class 3 is just a derived class. So an example of inheritance would be a character in a game. You would build a base character that has all the properties and methods for appearance, then inherit with an AI class or a player class, each having custom state and behavior. For a very simple game, that would be a valid approach.
Yeah, Nelson really dislikes inheritance, and it is extremely rare that you will find him using it.
But I do use it. I do use it
in moderation
when it makes sense to. When it makes sense to. When I have a base class that really does perform some feature, that makes more sense to inherit instead of, or in frameworks, like ASP.NET MVC makes good use of inheritance, where we have a base class, and the name doesn't matter, but I'm going to call its proper name. We have a controller. And the controller has a bunch of state and behavior on it. It has a bunch of utilities and features and other really fun stuff that we can use. And then we create our own controllers, like a home controller. And the home controller inherits from controller. And what that gives us is all of these features and utilities are now accessible from our home controller. So that's a case of inheritance that doesn't necessarily make me want to throw up. But the people at Fubu MVC, of course, would disagree with that. But whatever. This isn't a web class. The point is that in this particular case, this controller base class has a bunch of features that are utilized by other classes. Okay. So inheritance is all about, pretty much it's all about extensibility. Again, extensibility will impact your maintainability and readability, of course, but to a lesser degree. Inheritance is mostly about extensibility. It's about, I want to write my code in such a way
All right.
that it can be further extended on in the future by an unknown amount of things. So does anybody have any questions about extensibility or inheritance? Yeah, I try to keep the levels of inheritance to just 1 or 2 max. That's a good practice. Even in the cases where I find myself using inheritance, I don't think I've gone over two levels, even if, I don't know if I've ever gone more than 1 level, actually. But does anybody have any questions about that? Because the next one is going to be very important. It's not as scary as it looks, but it's very important. I think I'd lulled everybody to sleep. At least my handwriting's getting better.
It is.
I remember
way, way better than mine.
Well, it's way better than when I started using doing whiteboards in class.
No, you're doing a good job, and you know me. If I didn't think you were, I would just jump right in. And you've gone beyond just review now, and you're actually covering stuff that needs to be covered for tonight. It's very good, and you're talking about some really good stuff. So
Yay!
Continue.
Alrighty, so the next one is polymorphism. And polymorphism is actually, I'm going to delete abstraction for now. I'm just going to move it up at the top just so I can...
Yep, I feel better about that.
Because polymorphism is 2 words, actually, stuck together. Poly, morph. Poly means many. Morph means form. Polymorphism means many forms. Now, what I mean by that is in a lot of cases in object-oriented programming, we do things that were not previously possible in procedural languages. Object-oriented programming, again, I did say earlier when I was talking that all object-oriented programming is about this object guy. That's it. So if you can mimic, in whatever language you're using, if you can mimic the kind of behavior and feel of an object, you can do object-oriented programming, even in normal C. It's pain and it looks really bad, but you can do it. Polymorphism is one of the things that is significantly easier to do in an object-oriented programming language that has specific features available for it. And what polymorphism allows you to do is it allows you to define the behavior of your program in terms of abstractions. So I'm going to kind of go over polymorphism, and I'll touch a little bit on the concept of what an abstraction is too, as well, because they're both very similar ideas, or they're not similar ideas at all, but they're very coupled. I'm running out of space, but I kind of like having all this stuff on the same layer because it looks kind of cool when you zoom out. I'm just gonna move it. How do I? What's free trend? There we go. And then deselect. Yep, sweet. Okay, so polymorphism and abstraction. They're very similar concepts. What we do, what we would like to do in theory, now in practice, I'll talk about how the theory and practice relate to each other in the real world. But in theory, we want our programs to be fairly abstract. And that's black.
That was cute, and that's black.
I hit the X key on accident. Anyway, so we want our programs to be abstract. And what that means is we want to define processes. We want to create processes that have holes in them. So a process might go on for a while and then delegate to a black box, and then might go on for a while and then delegate to another black box, and then delegate to another black, or maybe it starts looping, and as it's looping, it's delegating to another black box. And then we want to have our implementation provide what goes in these black boxes. So we might have our implementation just needs to be 3 things, and these 3 things gets plugged in, just like a plugin framework or any other extensibility point in anything. The idea is that we should be able to create our implementation and then create alternate implementations. And our alternate implementations could also provide similarly shaped black boxes that can be fed in to the same points in the processes. Isn't abstract programming a form of contract programming? Yeah, we'll be talking about contracts when we talk about polymorphism. Because that's exactly what polymorphism is all about. It's all about contracts. But anyway, so this, in a perfect world, this is pretty much the holy grail of programming. And this is the diagram that we as developers will typically strive for at both the micro level and the macro level of our application design. In the real world, however, it's not so simple. And unfortunately, you can get trapped in going much too far into abstractness to the point where your abstractness causes more friction than just doing things in a concrete manner.
Correct.
However, it still is very important to keep this in mind because for certain scenarios, different problems have different levels in which you can get closer to this design. Different problems are more suited to a more abstract concept, and other problems are more suited to a more concrete approach. And so keeping in mind the availability of this tool of abstraction in your toolbox, it will give you another perspective when you approach a problem that seems like it's very conducive for abstraction. Certain things that are very good, very easy to abstract are very abstract processes. Like a very easy thing to abstract is a process that lists files, or a process that gathers a web page. I don't know. Very difficult things to abstract, and I don't mean this as far as the actual relationship between your views and your controllers, and of course we'll talk about views and controllers in the iOS class, but I do want to point out that UI design or layout design, specifically, not how the information gets to your UI, but how your UI is actually defined, is a very poor candidate for abstraction. Reason it's very poor candidate for abstraction, just to give you an example of why I consider UI and layout to be difficult to abstract, is that you very commonly have different UI screens that may share some similarities, but are different at different points. So you might have a screen that looks one way, but slightly looks different on another way. And if you try to abstract that, you end up with a very complicated abstraction.
Though,
so UI,
I just wanted to say, though, UI controls, I mean, there is heavy abstraction when you go like from NSObject down to the first responder, or excuse me, the UI responder, UI view, UI control, then like to a UI button, and then But again, we're not getting into the elements, but there's still controls that actually are used to make up.
I did not all mean for that. This is a really hard concept I'm trying to express, especially to people who haven't done any UI layout before. But what I'm trying to express as far as what's hard to abstract is not the control level. It's the way in which you combine controls to create a view.
Okay, that's better said.
The ways in which you combine a control to create a view is very difficult to abstract because different views will have very common similarities, but will have important differences that will result in your abstractions being very leaky and difficult to manage. So I just wanted to point out that some things are very easy to abstract and some things are very difficult to abstract. And if something is very difficult to abstract, it's typically best to not even try, because you will end up with a better looking program and a better functional program, a more readable program, and a more stable program if you try not to abstract it. But there are certain things that if you do not abstract, you will end up with a very brittle program. You will end up with a very unmaintainable program, and so on.
And right offhand, Mr. Lewis was asking, do you have any sort of real-world type examples? And Jonathan also says, can you give us a model example of abstraction?
There's way too many. Everything. These concepts fit into everything that you're going to do to some degree. Like I said earlier, to some degree you will have very abstract things, and in other places you will have very concrete things. A very simple example, a very real-world example. I could talk about enumerating a file, for example. So let's talk about what if I wanted to gather all. Why does all no? My hand was just on a roll. It was just moving without my knowledge. Gather all images in a folder. So here's our problem. So how do we model this problem? Well, I immediately see a point of abstraction. Immediately, I see a black box that should be able to be replaced. I want to be able to actually take this and get a blank space completely. And I want to be able to clean this up a little bit. I want to be able to replace this black box with whatever I want. Maybe I want to gather all documents in a folder. Maybe I want to gather all images and documents, videos, there we go, in a folder. And I want to be able to use this exact same process over and over and over again and simply pick and choose which one of these black boxes I want to fill in the blank with. So here's the blank. I can fill it in with any of these 3 that I want. And in fact, I want to also be able to fill it in with something that hasn't been figured out yet. That's where the extensibility comes in. So gather all blank in a folder. That's the concrete aspect to this problem. We're probably going to have a function. Or let's just make this fairly abstract. No pun intended, I was using abstract in different context. I'm just going to write a function. So we have a function, get files. Now, get files has a bunch of code in it. It does things like open up a the get files, the first step, the get files will accept a string telling it which folder it wants to get it from. And I'll have a bunch of code, and this code will do the operating system specific operations to get all the files in this folder. But when it comes time to fill in the blank here, how do we do that? How do we represent this idea in object-oriented programming? Let's say here's the blank spot. Right here is the blank. This is the blank, and this might be encapsulated in an if statement. It might be something like if blank skip file. I don't like that. If blank include file. So here's the pseudocode for this abstraction right here. If blank include file. So how do we get this blank? How do we provide this blank to this function? Close. We would provide an object to this function. And the object would encapsulate the concept of filtering by whatever it wants. So we can make a class that represents filtering by videos. We can make a class that represents filtering by documents, images, and then we can make as many other future classes as we want to fill in that blank with. So how do we get that blank? Well, we get that blank with a pointer called, I don't know, filter. So that's an object. And this filter gets placed into that blank. It gets passed in as a parameter to the function, and it gets placed into the blank, and now we have successfully completed this sentence. The sentence is now complete, and the function behaves the way we expect it to. Well, what goes in here? Can anybody tell me what goes right there? Not ID. Actually, Sion, I'm approaching this with polymorphism. Your class, good, but there's a problem. We don't have a type we can place in there because getFiles does not know about any of these. All of these types down here are hidden from getFiles. It does not know about them at all. There's a disconnect here. So how do we get files to know enough about the potential for other classes to exist in order to use? And Sion says you would use an abstract class. Exactly. You would use what's called an abstract class. An abstract class is also called an interface, or in Objective-C it's called, Jason, what's your cue?
Keep going.
I don't know what's called in Objective-C.
Yeah, you do.
Protocol?
Yeah. Now keep going.
Oh, okay. It's a protocol. It's a contract. It's an interface. And an interface is an abstract concept. It's not a real thing. In some languages, they have interfaces, but in languages that don't have interfaces, you use the next closest thing. In some programming languages, those are abstract classes, and others, they're protocols or contracts or whatever. Now, what exactly is that? I'm going to be referring to these things as interfaces just for my benefit, so I don't accidentally start mixing up terminology. If you guys just put on a filter and every time I say interface, you just hear protocol, then that would be great. But,
I mean, since we're actually going to start throwing around fancy language now, I would go ahead and say stick with protocol, because we're going to be using interface when we start getting into class definitions tonight. Just so that
right?
then people don't start getting confused.
Yes, I'm aware that in C# abstract classes are classes, not interfaces. But okay, so what we need to do is here is where the A word and the P word come in. Remember this disconnect? This squiggly line represents a disconnect of visibility. This function does not know of anything within the squiggly, but it needs to know something. So what does it need to know? It needs to have a protocol. And the protocol says a protocol is a type, like a class, and let's call our protocol iFilter. I don't know if Objective-C uses the I prefix, but I use the I prefix. So that's what I'm using, and that doesn't look like iFilter. I think the longer I go without a cigarette, the more my writing's degrading. iFilter. Okay, so this is our protocol name, and our protocol defines placeholders for behavior. So the placeholder for behavior would be, in this case, would be do return file. Here's the behavior that the protocol has. Well, the protocol doesn't have the behavior. The protocol has a contract for this behavior. It says that whatever class whatever class tells the compiler that he implements me has to return or contain a method or a behavior inside of that class that follows this format. Now, this iFilter protocol is known by this. This iFilter protocol is the abstraction. So that's what goes into this blank.
And just to simplify, basically what he is saying is that any class that is said to implement that protocol, and it gets a little tricky because with protocols you can have optional methods, but the bottom line is, just to keep things black and white, any class that implements that protocol will have those methods available. So you can safely call upon those methods for doing something, because you know that those methods will exist because that class is of type that protocol.
Right.
And
so like somebody said,
I'll see if I'll jot that down. As a matter of fact, I'll do it right now, and I'll see if I can put some more serious protocol stuff in next week if you guys want to see it.
Okay. But so this is the abstraction. How do I know it's the abstraction? Well, it's the blank spot. It's the fill in the blank here. That makes it the abstraction. It's abstracted away. We don't know what goes into that blank spot when we write the getFiles function. But we can pick and choose which one of these we want to be placed into that blank. So how do we accomplish that? Well, through polymorphism. Polymorphism literally means many forms. That is to say, this iFilter can take many forms. It can take the form of a video filter. It can take the form of a document filter. It can take the form of an images filter. Polymorphism just means that you have an abstraction, and that abstraction can be concretified by specifying a class that implements that interface or that protocol.
So now what he's saying is in each of those classes, the specific ones, videos, documents, images, they all must have their do return file. It's guaranteed, but their implementation of that method will be appropriate for the file type they are dealing with. I was just going to say that, Nelson.
Oh, no. I totally agree. I was just looking at Buzz to see if there was anything I didn't catch.
Oh, okay.
But this is polymorphism. Polymorphism simply means many forms. And it means that this type, this blank spot right here, can be of anything that satisfies what this type is. And this type is a contract, or sorry, a protocol. And anything that satisfies that protocol can be passed in. So what would the code actually look like if I were to invoke get files? It would look something like this. Get files. C. I know iOS doesn't have a C drive, but still. And then I would new up a videos filter.
Remember, this is very loose pseudocode that he's. Just don't look at that as in being actual syntax, please.
No, it's not Objective-C. It is pseudocode. But I mean, you did tell me to establish the new.
Yes.
Yeah. So this is how we would fill in the blank here. We don't fill in the blank inside the function definition. We fill in the blank when we invoke it, which means we can now reuse this to get all the file, to get all of the, how about we want to get all of the pictures or the images. So this video filter comes from here, and this images filter comes from here. And that's polymorphism. It should be pretty, I hope. This is actually fairly complicated stuff, and I'm probably going a lot further than Jason intended me to.
Just a tad. You mentioned polymorphic methods as well through inheritance.
Right. I was going to point out, though, that after I just got this example done, I do want to define polymorphism a little more, because this is just an example of polymorphism. There are different ways to accomplish the same thing. But I just want to make people at least aware of this example and make sure that they kind of understand what's going on here. The whole point of this entire thing is just jumping back to here. This is abstract or abstraction. We have processes that contain concrete implementation details, but then we have black boxes. These black boxes are filled and can be filled with different kinds without actually altering the process. The next important thing with abstraction is that if I change, let's say I change this line of code right here. So instead of squiggling like that, it squiggles like that. So I've changed this line of code, and that means that every time the get files is invoked, no matter what is passed in, that change is reflected. That concept increases maintainability and stability significantly. It also increases extensibility significantly. The downside to abstraction, and what will happen if you do too much of abstraction in your application, is your readability will suffer. as well as probably your maintainability, but most importantly, readability. Abstract concepts, like I said, some things are very predisposed to being abstract, some things are not predisposed to being abstract. Know the difference and know when to apply it and when not to. But it can be incredibly, ridiculously, insanely, stupidly effective when used in a proper scenario. But anyway, like Jason was talking about, polymorphism and abstraction isn't just like all of object orientation. Polymorphism is a concept. What I've shown here is actually a semi-concrete example of using the polymorphism example or a concept and using the protocols as the way that I implemented polymorphism. But there's also another way to implement polymorphism with inheritance. Here's a nice blue spot. This kind of makes me think of when I used to play SimCity, and you're just like panning around your city trying to find a nice big blank spot of land to put your power plant. But anyway, so polymorphism could also be implemented with inheritance. So let me use that exact same example, but instead of using interfaces, I'm going to use inheritance. So what I'm going to do is I'm going to start off with a class called File Searcher. And File Searcher has a method that returns files called getFiles. And it takes in a string called folder. Now, I don't know how much this can be difficult without talking about accessibility. Well, I don't have to talk about accessibility. What I can do, okay, so we have the getFiles method here. And this getFiles method has an implementation. Here's the implementation. But it also has, of course, because we want to make this abstract, it has a black box that isn't implemented, isn't defined. So where does this black box come from in this example? Can anybody guess where this black box is filled in from? How does it get there? Well, the answer is not a parameter, because now that we're using inheritance, we have an additional tool that we can take advantage of. What we can do instead is I can make another function, another method on the same class called something like filter file. And the important thing about this is I'm not giving it an implementation. I don't care if that has an implementation or not. It might have an implementation. I mean, just for the sake of simplicity, I'll put an implementation in. This implementation is just going to say return true. So basically, our file scanner now is going to return every single file underneath this folder, because his filter file method is return true. So does this make sense so far?
So just keep in mind that box that Nelson drew there is actually just a simple method call to filter file.
Right. It's something like if filter file is true, then add file to return. So that's what the black box is, essentially. Okay, is everybody following along so far? So what if I wanted to make a more specific, actually I don't even care about that stuff. What if I wanted to make a more specific file scanner? Well, now I can go ahead and create a class called video scanner. And again, this is just pseudocode. So I'm just going to say extends file scanner. Now file scanner is up here. And by saying extends file scanner, I am now creating a subclass of file scanner. And this video scanner has everything that file scanner has, except for I can add more things to it. Or I can replace things within it. For example, I can write my own filter file method. That returns true if video.
So in essence, he is now overwriting the functionality that is in the base class's filter file method with a new implementation.
Right. So this replaces this, but it's important to realize that it only replaces this file from within instantiations of video scanner or video. Is it video scanner? Searcher. Is it searcher? I don't know what that is.
Searcher, I think is what you said originally.
Okay, searcher. So that means if I do this, if I say video scanner pointer equals new, and I'm not even going to finish writing that out. And I need to give it a name, of course. So video scanner, I'm going to call this S1 equals new ... And then I have a file scanner pointer S2 equals new ... When I say S1 dot search files, here's what happens. Remember that S1 is a video scanner, but this search files is not defined on the video scanner. It is defined on the base class, which means this search files invokes, or get files, whatever, invokes this method. But something interesting happens. Something incredibly fundamental to what we've been talking about in regards to polymorphism and abstraction. When this S1 scanner, or this S1, goes to implement each one of these lines of code one by one, when it gets to the black box, where is execution going to go to? When I do s1.search files, where is the execution? When it hits this black box, it is going to literally skip right over the default implementation and use my overridden implementation. But if I did s2.search files, here's what happens. Everything happens. You know what? I'm actually going to take advantage of the fact that I'm in Photoshop. Everything happens the same. Where it hits this line, then that line, then that line, then that line, and that line, and then it hits the black box. And where does it go? Well, when it hits the black box, it goes to the default implementation of filter file. So this is such a common pattern in programming in all object-oriented languages that I've ever seen, even non-object-oriented languages, in fact. Well, JavaScript kind of is. JavaScript's weird. I'm not going to talk about JavaScript. But anyway, this is such a common pattern that you'll see in so much that's actually been given a name, and it's called the template pattern, or the template method pattern. And it allows us to use polymorphism to override the implementation of something so that we can give more specific concrete implementation details. whenever we want. This example is the exact same, pretty much, as this example. The only difference is this example takes advantage of protocols instead of inheritance. Okay, so how many people are just lying dead on the floor with froth coming out of their mouths?
Nina, for one. It's okay, because we're about to take a break, and then I got to turn the heater on because she's freezing on this side of the house and dozing off. So.
Hold on. The ones asked, is one better than another? And, well, Jason knows which one I prefer.
You know, the most important thing to understand is there is no black and white. You should always do this, you should always do that. The more that you practice your programming skills, the more you'll begin to recognize when you need one over the other. I think polymorphic methods are fantastic through inheritance. At the same time, I totally agree with Nelson that the moment you start extending things a little bit too far, it quickly becomes a mess because you end up with so much abstraction that it then just becomes difficult to actually read through someone's code, kind of piece together so many abstract ideas before you finally get to concrete implementations. And these are things that I would love to spend more time on in a development class itself, because we're on the edge of Pandora's box here. It's an interesting set of debates, arguments, all sorts of good stuff. But the more you work with it, the more you work with object-oriented design, the more comfortable you will become at recognizing when to use one or the other. I mean, does that sound fair to you, Nelson?
No, it's certainly fair. I mean, the fact is I do prefer one over the other, but there are going to always be instances where my preference isn't the most optimal way to do something. And that's true for everything.
And there's been times in the past that I've watched Nelson actually code something where, to me, I would have used inheritance because he was using, in the Objective-C world, protocols, but in C# he was using interfaces, and he was Nelson, video's recording, my friend. Let's keep the file from being too big. But he was rewriting a lot of code over and over and over, and those were some of our fun arguments in the long past, when you can get away from rewriting code over and over and over when using inheritance, because objects or classes that extend base objects or base classes, automatically get that code, so you don't have to reinvent the wheel. But again, Nelson is very much against inheritance in most situations. Me, it comes down to what I'm doing and which approach I find applicable or not.
Well, I mean, that's the same thing with me. It's just I've seen
you hunt for a way to not use inheritance, and you know it. We've argued about that, so don't even.
The problem is that there are so many examples of abuse.
Sure, I mean, again, it comes down to practice and being able to recognize, when you're. All because you can abstract something and you've read that in a book. You don't want to be like, man, I'm going to be cool. I'm going to extract this and I'm going to abstract it more, and it's going to be so abstract, man. Even I don't know what it is. It starts out with it's got like float X, and then we inherit from that, and everything. It's not like that. You're absolutely right. You could get it to where it's just, ugh. But
that's exactly what I said.
I know, but. At the same time, you do always try to look for a way to not use it at all. And I think that, it has its uses. But with that, let's go ahead and take a break. I think this is a good spot. You've covered everything in pretty great detail, and I know some of you guys might have been sitting here, you know, kind of just trying to drag along and follow what's going on. This stuff is very important and is going to become extremely important as we start getting into real application design with the iPhone apps. So, yeah, this is fun. This is foundation stuff. Absolutely, Jonathan, especially for application development, real-world production. So I'm going to go ahead and hit pause. We'll take a break. When we come back, I'll go ahead and pull control back from Nelson, and we'll start building all of this up. Hello, everybody, and we are back after that incredible break. So what I want to do now is just jump right into stuff and things. Let's jump right into defining classes, because we know after everything Nelson talked about for the last, hour plus. Hang on. There we go. That's better. We know that we need to be able to create classes. We need to be able to define classes. And from those classes, we need to be able to create objects. And then everything Nelly talked about will just all come into focus. So if you guys recall, and remember I said at the beginning I'm going to continue talking about the last class as if it was last week. So in last week's class, for the second half of it, we did an object-oriented programming Hello World application. It was a very simple one where we had created a message dispatcher class, and that message dispatcher was very, very simple. It allowed us to go in and basically just give it a message and then show that message. But it allowed me to do just a little bit of demonstration as far as how manual memory management works with Objective-C applications. Because again, getting into our automatic reference counting, the thing to understand is it's not real garbage collection. There is still basically, when we get ready to compile, right before the compilation takes place, what happens is a process is going to go through, analyze the code, and it's going to inject all of the proper retains and releases based off of all of the clues that you set forth in your code for the compiler or for this process to pay attention to. But I still think it's very important to have a solid understanding of how manual memory management works. So we will continue with that approach here at the moment. And so defining classes, as I had mentioned last week, there are two sections. Oh, bear with me. I gotta get my comfortable feel going on here with the pen now. Okay, I'm comfortable. So in defining classes, our two sections are going to be comprised of the interface. And that's why I wanted Nelson to be cautious when he was talking about protocols earlier. I don't want us getting into protocols right now. They are extremely powerful. They play a critical part in real-world application design. In the in the C# world, they're called interfaces. Well, working with classes, one of our sections is the interface, and so it's very easy to get yourself tripped up if you're a beginner and you're hearing, these two different terms being swapped back and forth interchangeably. It's not necessarily a good idea. Okay, so interface is one of the two sections. The other section is the implementation. Whoa. Now, syntax. Let us look at the syntax. It's very simple. We're going to start out with, so let's look at first our implementation. our interface. And if you guys recall, last week I had told you that while we could put this all into a single file, that's not how we're going to want to do it. What we're going to do is we're going to break up our interface into the header file, and we'll put the implementation into the implementation file. So our interface is going to be .h, and our Implementation files for Objective-C are going to be our .m files. So let's start out with our, let's just say that we're putting a class together called MyClass. So let's kick things off with a look at the header file. So first thing we're going to find in there, since we're going to be using Foundation, we're going to find an import. And I told you guys about import, a little bit different than what we were using in C. What does it give us? What did I talk about? Huh? Anyone? Bueller? Nina?
I can't remember. Oh. Okay.
No.
Wait,
no.
What?
Nope. Nobody's even throwing in. Oh man, come on.
Oh my God.
Includes, okay, but better than includes. Why is it better than includes? It's like having an include on steroids. All right, Jonathan doesn't remember. That's okay. He dozed off during that part. One of the problems that you can get yourself into when working with includes in the good old world of C and C++ is you can get yourself into cyclic conditions with includes, and then you have to get in there and you have to start basically checking with preprocessor directives, checking to see if something has already been included or not. Well, when using our import is kind of like an include on steroids. It's going to make sure that you don't have any, well, yeah, as MMODust just said, any duplicate includes. You're not going to run into a cyclic condition where you may have one file that is saying, I want to use this header file, and then you've got another guy that's going to use the same header file and that other guy. So now the header file is being used twice, and you can get yourself into some very interesting situations. Well, I hate to say this, but you can be sloppy all day long using the import directive because it's going to make sure that you do not get yourself in that kind of a situation. Now, we would have any other types of imports. You guys saw that we were able to go in there and even use our pound import with the standard IO header, just from the standard C library. It's not like we're going to use part of standard C library stuff and have to suddenly jump back over to using pound include. Okay? So I only need to import a header once, and it's global. No, not quite global. It's not like that. If you have two files, and one file is going to be importing another file, basically it's going to make sure you don't get into a situation where you're trying to include the same header file in multiple files that end up referencing or using one another, where then if you were to take a look at all of the code combined flatly or in a flat state, you would see that the include actually took place multiple times, which would be bad. You don't have to worry about that when using the import. You're going to get a global feel out of it when you say import something in one header file. So let's say this class uses some other header file that we're going to import, and then we have another class that makes use of this one, will automatically gain access to the other one. So that's not really global, but it's kind of like that. And yes, Jonathan, circular reference protection, exactly. You will not get into those cyclic conditions. So we're going to start out with our imports. From there, this is very important. We're going to come down and tell our compiler, here's our first section. This is going to be the interface section. And this is where we would have our class name. And then what we are extending. And in this case, we are extending NSObject. Now this is Objective-C. And everything that we're going to be writing in Objective-C when actually working with the various utilities, types, etc. that are provided to us in the Foundation framework, it's all NSObjects. That is the root level object. Now, let me go ahead and, because this will become kind of important. Wow, is my thing really that small? Jeez. Nina, hush. Jeez.
Really?
Jeez. Is my document really that small? So
Oh, that's what they call it these days.
So here's NSObject.
I was just laughing at your small document.
Mm-hmm. And then from from NSObject, in this case here, based off of the interface that I've defined in my header file, this here is my actual MyClass object. And since I am extending NSObject, there's a lot of things that I'm going to get from NSObject that are very important, very crucial to how, well, we're going to be utilizing Objective-C objects and all. For example, you guys saw last week Alloc, for allocating the space required for our object. That's where it comes from. You guys also saw Init last week. That's where it comes from. You also saw Dealloc last week. Again, that's where it comes from. And then you even saw a quick showing tonight from Nelson. I told him he could use new so that he didn't have to write out Alloc and Init. And we'll talk about that. All that is just kind of a shortcut for doing the two if you have no parameters that you need to, or no data members that you need to initialize upon class instantiation. And then, let me think. Oh, description's also a good one as well. That's enough. So anyways, every single object in Objective-C that we're working with that comes from Foundation, or that we're creating and plan on taking advantage of Foundation with our objects, all have these types of things available to it because they all derive from NSObject. So right here, that's all we're doing, is this is where we're saying, all right, we're now going to make our new object, and it is going to extend this object. So you can say, and I've always found this to be very important to understand, you can say that MyClass, that's the type, MyClass. But MyClass is also an NSObject because it has everything that an NSObject has. So that's really important. Whoa, hey, how you doing? Undo being funky on me. Okay, so we now have our at interface. Now inside here, this is going to break up into a few different areas, into three different main areas that we're going to be focusing on. The very first thing is going to be our instance variables. And these are marked with both a starting and closing, it's just a block. There are curly braces. So I'll just come in here and I'll just do it like this, ivar type, and then identifier. So just as an example, if I was to come up underneath this and actually make a real one, I could say, you know, I've got an NS string pointer, and maybe I called it name. So this is an instanced variable. And what that means is that when this class is instantiated, we talked both last week and Nelson mentioned it again this week when going back over object-oriented programming concepts, the concept of state and behavior. And this is where our object is deriving its data members, its own data members in which it's using to define its state. So I can instantiate this class here and set name to Nina. I can instantiate the class again, set name to Nelson. And I have two different objects of type MyClass that both have different state than one another. Okay, so now that's again where we define what are typically known as our ivars. So the next thing is going to be our properties, and we're going to be covering properties tonight. So I'm going to go ahead and write these in, and again, we'll come back to these. So another directive in there for the compiler saying, look, we want to define a property, and we've got to tell it that we're going to have specific rules if the property is going to be synthesized that need to be followed. So let me say that typical ones that you're going to see: retain and non-atomic. Hello. And then we get back into, again, the variable type. I'll just say type. And then we'll have our actual, again, an identifier. I'm just trying to think of how I want to write this out. For example, I'll do just like I did above with the NS string. So I could say, and I don't know why I wrote properties, it's property. Just notice that, R-O-P-E-R-T. So property, and I want this to retain. I want it to be non-atomic because I'm not going to be doing anything with threads. There we go. So now I'm actually defining or setting up a property for this guy right here. And our protocol is the same as we've got to get off of protocols altogether. I will add that into lecture for next week and give that to you guys. I don't want us to get pulled down with that right now. Okay? So, Jonathan, we'll get back to you, I promise. Where is the star, the asterisk? All right. Again, let me just keep going through the syntax here, and then we'll start breaking all of this down into very specific stuff, including getting into the properties and how they work. So, and that is why I'm writing things like just type an identifier, because, well, in this case right now, since I've got retain there, I can definitely go ahead and put a star there. But properties don't have to be for object types only. They could also be used for NS number or, well, excuse me, let me give a better example, NS integer. So we still have a value type. So when dealing with a value type, we're not going to have a retain on it because the compiler would give you an error because you cannot retain a value type because it's not an object. So in that case, using retain, I would definitely see an asterisk there. Okay, so after, geez, come on, Photoshop, thank you. Let's go and put that back. Okay, so after we have all of our properties, then the next thing that we're going to have will be our prototypes for our methods. So we've got our return type. And then our method identifier. And then let's say this one takes no parameters, and then another return type. Another horribly spelt. So another prototype, except this one, let's say this one took in some parameters, so I could say type, and then parameter 1. Actually, I'll just leave it at that since I'm running out of space quickly here. And then finally, we wrap this whole thing up with at end. So with our at interface, we must have our at end, and that's going to close everything up. So everything that is inside of those two directives is going to be the actual interface for our class. So again, class name, extends, what class that we're going to be extending, a block comprised of course, our opening and closing curly braces. And inside our block are our data members. And typically referred to as our instance variables, or often just IVARs. Next section, properties. And these properties here, we mentioned this just a little bit last week with accessor methods, the getters and setters, if you guys recall. You know, what was it that we did the dispatcher, and with the dispatcher, excuse me, if you guys recall, we had a message data member. And so we exposed two methods that we defined on our class. One was the what was it? The getter, one was the setter. So one was just message, and then the other one was set message. And then using those, we were able to externally set the message data member inside of the message dispatcher instance that we had. Well, using properties, we can have, properties are different. With properties, we can have the compiler actually synthesize the getter and setter for us. That's number one. Number two, you cannot have functional code in a regular data member. I got to be careful how I say that, because yes, you can, but that's very advanced. But with things like, you know, a weight. Let's say that a weight's just going to be an NS integer, right? So 0, or maybe even an NS unsigned integer. So it's just going to be a number, but what if you wanted to have some functionality with weight? Then by using properties, you can go in and actually add functionality to interface with that data member. And I'll make that make a lot more sense when we talk specifically about properties tonight and we start writing them out and you see what's happening. But by coming in here with this preprocessor directive saying, compiler, look, we're wanting you to create, I mean, this is what's basically being said right here. We're wanting you to create a getter and a setter method for us. Here are some special instructions on how we would like the functionality of that getter and setter to work. And then, of course, we need to give it the type and the identifier. So that's what's taking place there. This is a way for us to go in and by using @property and @synthesize, let the compiler do a lot of writing for us. It just makes things a little bit easier for us. So then after we go through and we define our properties, and again, I will be coming back to that, the final thing, the final section in this will be our prototypes for the methods that we will have on the actual object. Now, please bear with me for a second. I want to try something. So, did my size get chopped way down or something? I'm sorry. This is why I'm stuttering a lot at the moment for the last few minutes. It's just been completely blowing my mind while trying to write because the document size is completely jacked up.
A third of the size that it usually is.
I know, and I'm like, what's going on here? So,
did you up your DPI?
No, I haven't messed with anything extra.
Weird.
Wow, look at that. Yeah, I guess I just zoomed in a whole lot further, but I did the command. Hang on. Let's just go ahead and jump back over here. Yeah. That's what I get.
That was weird.
Nope, that's my fault. Alrighty.
Zoom, zoom, zoom.
Yep, now we're going to zoom.
Okay, there we go.
Okay, so what we just now, I won't have to be all confused as to what the heck's going on in my mind. Okay, so that was looking at my class header. Now let's go ahead and take a look at, as I hide out the layers panel, our implementation. So here's myClass.m. And in it, of course, we're going to start out with our import. And what are we going to import? While I'm writing this out, I better look over there, buzz that in a second, and everybody better have said it. I'm looking. All right, very good, Jonathan. Wait, where's everybody else at? Oh, you're a little slow, Mandrill. All right, I'll accept it. I'll just pretend you guys have bad lag. You guys are absolutely right. So we've got MyClass.header file. So we bring the header file in. And the next thing, we're going to come in here and we're going to tell the compiler that this is going to begin the implementation section for the MyClass class. So implementation, I really need to turn that off or deactivate the button. So implementation, and with this, all we need to do is just come in here and give it the class name. And again, we've got at implementation. That means we're going to need an at end. So, and which we'll get to in a minute. Now I'm going to throw in a couple of other fancy things that I've already mentioned a couple of times, because this is going to be something you're going to typically see when using properties. So if you're using the at property directive, you're going to generally see the at synthesize or the synthesize directive. And then whatever we called them back over there, we'll just call this like some var1. Just keep in mind, I just don't want to flip back over to the other massive size thing. Whatever identifiers that we used on the properties, which reach all the way back through to the instance data members, those identifiers, they all need to be the same. You can have different named getters and setters created for you, but we'll talk more about that a little bit later. So right now, same names. So whatever I use with at property as the identifier back on the header file is what I need to use here. So let's just stipulate that back on the header file, I used the first property was some var1 and the next property was some var2. So we'll synthesize the other one. And then from here, hang on one second, our data members within an implementation that are extra, not included in the definition, considered private. Very good, Jonathan. Yep, we're going to be talking about, since they don't actually have a public and private mechanic like a lot of you are used to from other programming languages. It's basically how we control what is exposed through our interface as to what is public and what is private. So yes, and we're going to look at that a little bit closer here in just a bit. Okay, so we synthesized, and then from here the rest of the implementation is really straightforward. We just need to take our prototypes and define them now. So the return type, and so I'll just say method identifier 1, and then now I was about to put a terminator, though interestingly enough, the terminator is valid over here in the implementation. What you have to have, though, is you've got to have the actual implementation. So you've got to have an opening and closing curly brace, and then your implementation inside. This guy here is optional. I don't like him personally. There's some pretty interesting debates on the internet that you can find about it. They can be kind of convenient because you, over in the header file, set up all of your prototypes, and then you can just highlight them, Command-C, and then Command-V over in the implementation, and then just add in all of your opening and closing curly braces and not have to worry about taking off all of the terminators, and everything is completely valid. Mm-hmm. So it is valid, but it'll drive me crazy. So we had 2 back over there. So since we had two, let's go ahead and just put it here. And for the sake of time, we'll just stipulate that other one I just called method ID 2. And then we had a type on it. So it actually took in one parameter, or took in one argument. And I think I called it param1. And then again, an actual implementation needs to exist for them. And then finally, at end. And so just like we saw with our interface section, with our compiler directives here, we're able to say this is where the implementation for this class begins and this is where it ends. Then we take care of synthesizing. This is where we're going to turn around to the compiler and say, look, go ahead and make those getters and setters for us. And then we come in here and we actually implement the methods that we have declared back over in the header file. Simple enough. That's the whole process. And from there, it's just a matter of actually instantiating a class, and we're ready to rock and roll. Now, you'll notice that I'm using these minus symbols here. What were those again? Simple question. I talked about it last week. Nina, what was it?
I can't remember.
You can't remember? Private? No. Ah, Terry. Okay.
Wait.
There we go. Mr. Lewis remembers exactly how I said it. That's what I'm looking for.
Methods.
Basically, what we've got is the instance methods, and we have class methods. Class methods reside at the class level, so you do not have to instantiate a class in order to call a class method. You just actually talk straight to the class. And we did that. As a matter of fact, I'm surprised Jonathan wasn't the first one to throw an answer out because he goofed his all up. I do remember that. So, yeah. Okay. I was AFK. You did goof it up last week. I remember that clearly. So, very simple in setting up a class. Again, 2 files, and it's all about these 2 major sections with defining an interface and defining our implementation. And the interface is what is exposing functionality that you would like other classes to be able to take advantage of. So interface is actually pretty important. And as Jonathan was hinting at a few minutes ago with one of his questions, it's through the interface in which we can control what becomes public and private, because if we don't define it over in our interface, then other classes will not have access to it. So, next thing I want us to look at is instantiating some classes. But you know what? I've done a little bit of writing. Bear with me. Let me jump back over into, there it is. Oh, look at this little cute program. So last week, we've got a couple of new people in the class this week, and I'm not going to have you guys follow along, so we're going to be moving on a little bit quicker. Jonathan just asked over in the questions panel, in Objective-C, is public and private the only accessor methods that the language has? Yet we don't have a public and private ability that you're normally used to, that mechanic. So, okay, so what I want to do is let's go back through the message dispatcher real quick. Based off everything I just said, I don't want anybody following this time. What I want to do is just, so again, just follow. I'm looking away from the screen for just a second because I keep looking over there to see what's popping up and it's keeping me distracted. So bear with me for a few minutes and then I'll look back over there. So what I'm going to do is I'm just going to come in here and hit Command-M and then, or Command-N, excuse me, for a new file. I'm going to make an Objective-C class. Go ahead and hit Next. The class name is going to be, remember, our file name Class name, same name. Message, dispatcher. And then what we can go ahead and do, put our class name in there, and then I'll just go ahead and create it in the basic folder that we're in, and it's going to give us our header file and our implementation file. Now the funny thing was, just a second ago, I was about to type in the .h. If you guys recall in last week's class, when we first started doing this, I had you guys using a blank file. So we had to actually go in there and create a header file and create our implementation file. You guys are past that point now. So now I can go in there and start using the templates that are available to us. So, and I see Nina over here kind of looking and all. I'm just a reminder, don't try to follow along here.
Okay.
Relax and just try to absorb and say, yeah, that's what we just talked about over on the whiteboard. I see what's going on. So kicking off, I've got my import going on. And if we recall, I also had an import last week for the, what did I bring in? The standard io.h file. And then inside of our interface, what we have is only one data member, which was NSString. And with NSString, we called it message. From up underneath here, we did not have any, no properties. So now we have all of our method declarations. So we had a NSString pointer as a return type, and we were going to return the message. And then we had a void type, and we had set message. And set message took in one argument. So the parameter, again, as I showed over on the whiteboard, starts out with first the type, and the type is going to be an NSString pointer. And we'll just call this new message. And then we had one more. That's why I'm doing this again, and let me get this typo out real quick, is this is just such a quick example when I don't have everybody following here. So now I'll have the final method, which was going to be our dispatch message. And then that gave us our header files. I'll go ahead and Command C to copy these guys here, and Command S to save. Let's jump over here to the message dispatcher. And then inside the message dispatcher, all I need to do is paste these guys. And now let me show you what I was talking about a few minutes ago, then I'll come in here and clean it up. So you notice how we've got errors, and we're about to, boom, get out of errors. See, I haven't gone in and turned off the, that's what I get for looking over at BuzzNet. I haven't gone in here and taken out the terminators, but the code was fine exactly how it was. So now we want to give an actual implementation for this. So we're going to start out with message by simply returning message. If you guys recall, with set message, things got a little bit more interesting because we had a little bit of memory management that we needed to do. So the very first thing that I wanted to do was to take that new message that's being sent in, and I want to send a message to it. So new message, and what was that message that I wanted to, do you guys recall what it was? The message that I want to send to it. You got it. I want to retain it. So after we retain it, now I want to turn around with the message. So now the message I'm talking to, this is our local data member here. What do I want to do with this guy? I want to release him. But what is he set to by default when I first instantiate this class? It was also something I had talked about last week. Nil. That's right. He's got nothing in him. And one of the awesome, awesome things that I do love about Objective-C is the fact that you can, objects that are nil, you can send message to those all day long. It's just considered a no-op. So there's no operation that's going to take place. It's no error, and it's really cool because you do not have to go in there and test it to see if it's nil first before sending a message to it. So that is very, very handy. Okay, and then from here, all I needed to do is say, all right, well, let's just take our message and take that new message and assign it to the message. And then finally, let me put a little bit of spacing in here. For our message dispatch, what do we want to do here? You guys got to get involved more. Talk to me. What do I want to do? Give me a line of code to type. I want somebody involved. It's all too quiet. Okay, Terry says I want to do a printf. Okay, that's a good start. But if I just type printf with nothing else, it's not going to work. So, ooh, look at Mandrill all over this stuff. So he says, well, let's go in there and we're going to use a regular C string and we're going to use a format specifier, a %s like such, and then we're going to say comma, and then we're going to do another message. The receiver of the message is the message. And because remember, an NS string is an object. So with NS string, I can still go in there and do all sorts of regular things to it. Bear with me 1 second. He's in Chattanooga now, should be here in 2 hours. What are we at? 9, 10, 11, which is about what I said. So, Okay.
I thought he was going to be later than that.
Jonathan asks, why print F over NSLog? Because, and Mr. Lewis is spot on, because NSLog is going to give you a lot of log-like information. I mean, we could take the time to write our own version of NSLog so that if we wanted all of the fancy stuff, we could have it. But right now, this is just a very quick approach so that we have a nice, clean console that we can put stuff out on. Plus, the idea was to show you guys mixing what you had learned from the first couple of weeks. Because remember, Objective-C is nothing but an extension to C. So everything that we have in C is still available to us. So that's right, Mandrill. You tell them. So we're just going to come in here and say we're going to do a message. And then C string using encoding. And the encoding that we were going to use is going to be NS UTF 8 string encoding.
I remember that one.
And then very good. And then we can go ahead and terminate that. Now we did have one more thing that was very important. Let's jump, and again, some of the reasons I'm wanting to do this example again, but just at a much faster pace. I didn't have it up there, but I can just draw it real quickly again because I just don't want to go to that horrifying page. We have NSObject, and on NSObject we saw that it has nice little things like, I'm not going to draw them all, just do a couple real quick. And then our most important one, Dealloc. So we need to send, as Matthew just said, we need to send a deallocation message to our class. Because remember, we've taken this guy, we've extended him with our message. I'll just say that's our message dispatcher. And we need to come in here and we need to override Dealloc. You'll notice I didn't jump into the header file and put a prototype for Dealloc in there. It already knows about Dealloc. That's already defined. We've inherited it. So all I need to do is simply give it my own implementation, which will, and it'll override it. So don't think overwrite, think override. So I'm going to use my Dealloc to do a little cleanup, but then I'm going to call. So remember how Nelson said that this was the base class earlier? And this down here is my extended class. to my extended class, this base class we can refer to as super. And so by sending a message to super, I'm now talking to my parent class. And that's very important because Mandrill's all over this. Before I could even ask, he's already slapped down the goods over in BuzzNet with the answer. Man, Mandrill came in late, but he came in ahead of the game. I like it. So let's go ahead and take advantage of that ability, because we do need to do some cleanup because of this little thing right here. We've come in here and we've said the very first thing that we did is we did this retain, then we released this other guy, but then we took that other guy and we pointed him to the guy that we just retained. So our retain count is up by 1, and we're going to talk about memory management more. So for those of you that are sitting in this class as the very first Objective-C class, don't freak out. I've talked about a lot of this stuff last week. So make sure to go back and watch last week's video. But we will be talking about memory management in careful detail along with the rules here in just a little while. But we've got a retain count that's up by 1. So what we've done right here is we have basically put a stake in the ground. We have declared ownership. We own it. Because someone else can now release it and they don't have to worry about it. But we've caused its retain count to go up by 1. And remember, when a retain count hits 0, that is when the object is going to be deallocated by the runtime. So by making the retain count go up by 1, that's us being, nice and confident now that we can, at some other point later in this class, still make use of message without the fear of it being deallocated and gone. If message is deallocated and gone, meaning it's just nil, then we have a memory bug somewhere else in our program where we have released one too many times. Okay, so we need to go ahead and I'm going to use my pen. I don't think so. Let's go ahead and jump down here. And once again, as Mandrill was so kind a few minutes ago to point out, we're going to use Dealloc. Now, get into the habit of doing this right away because this is critically important. The very last command when you're overriding Dealloc is to call super's Dealloc. If you do not do that, you are cruising for a bruising. You're seriously looking at creating yourself some serious headache because the NSObject itself does a little bit of cleanup. These objects, each of these different classes, base classes, they do some stuff that, is important for their particular part of the implementation getting cleaned up. So, look at you, Delloc, thank you. So I personally like to just go in there and call upon super's Dealloc, like right away. And let me spell it right. What's that, Nina?
You forgot your A. I was just telling you about the spelling.
Yeah, I got you.
Oh.
Can you guess where? Wrong place.
Yay! Perfect.
So what we need to do now is to come in here and actually release our message. I'm going to be saying the word ownership quite a bit a little bit later on, so I'm going to start doing it now. Again, we have said that, come on, hang on, let me grab the mouse. It'll be a lot easier than this stupid touchpad. We have said right there that we want to come in here and we want to retain the this new message, which ends up being the object that message is pointing to. Because remember, this is just a variable. I mean, it's just going to hold an address that's pointing to the actual object. We want to make sure that the object sticks around, so this is why we're going to retain it. So it's now retained, we need to release it. Now, I just saw a question that said, when is new message released? Well, that's the interesting thing. if you think about it, it's about the object that's being released. So at this point, this is just a local variable, if you will. It's just a local parameter to the method. It's the actual object that's in it that we're interested in. Okay, so if we came back over here on the whiteboard, and when we create it, so let's say that right now, this is on the heap. This is our message. And right now, the compiler just initialized it to nil for us. So we come along and we create this new guy over here. And so he's going to end up being our message. But this is just an identifier for a variable. What have we really created here? This is an NSString object. That's what we've really created here. That's very important to understand. Message, new message, those two guys, they're pointers. They're just holding addresses that's pointing to this guy, which is down here chilling on the heap. It's an awesome place. If you've never been there, I highly recommend it.
The heap rocks.
That's right. The heap is awesome. So now we have this message, and we'll say that its contents, basically its text is hi. So now, and he has a retain count on him. I'll just say RC. The variable message is not the guy with the retain count. The variable message, so this is our IVAR. I'll just say, man, I'm horrible today, MSG. So this guy right here, remember the good old stack? We spent lots of time, Nina's got the hiccups. We spent lots of time talking about the stack. This guy is just a pointer, and he's pointing the places. The compiler, by default for Objective-C, is going to make sure that all of our guys are pointing to nil for starters, okay? And even then, drawing it out like this isn't how it is because we haven't actually allocated any space on memory. So keep that in mind. This is just a graphical representation to kind of give you an idea of what's going on. So right now we're pointing to nothing. So if I was then to turn around and say that, let's say that we're going to do a release on MSG. Well, what is MSG? MSG is nil. And what did I say? You guys can call messages all day long on a nil object. Nothing happens. It's a no-op. So no operations are performed. Doesn't hurt performance or anything. So nothing happens. Now, if I said, take this other guy, and so let me give another guy. So we'll stipulate I typed out or wrote out NSString, and we'll say that this is new message. And so now I just passed in new message. So, boy, this is the worst pseudocode in the world. This is so awesome. So actually, it wasn't right there. Here is my awesome method signature with the NSString. Oh, really? Okay, so with NSString new message, and fine, there. So the first thing I did is I sent a message to this guy. So now let's say this is the guy that's being sent in. So now I can come in here, and if I say, well, let's take new message, and let's retain it. This is the receiver. This is the method that we want to send to it. And what most of us that are coming from other languages are used to hearing, this is the method we're going to call. But they say it as this is the message that we're sending. So we're now going to say retain new message. Well, new message, remember, So here's new message sitting on the stack, blah, and he's pointing, wee, to this guy down here. So the message actually goes to this guy down here, and whatever, let's pretend retain count was 1. So if it was 1, it just up to a 2. Okay? So that's all we've done there. So now we've turned around, and now if we say, let's go ahead and say message, release. Well, he's pointing to nil. Doesn't matter. He's off in la-la land. But now if I turn around for the final time here and said I want message, because remember, on the stack, here's message. I want message to equal to my new message. All we are doing is just updating this pointer right here to point to this guy here. So now I can say, what is my message's retain count? What's my retain count, guys? Oh, quick, what? I'm pointing to the daggum thing. 2, thank you. MMO Dust, what are you? What? Oh, now you just want to cover it up because you so put your foot in it and you're like, ooh, I just stepped in poo. So let's just throw out some other numbers and try to mask it. But I do appreciate the fact that you're at least throwing something out there. And Warhammer, where's your participation, sir? Participate! And LOL is not considered participation. So that's the important thing to understand here. And this kind of goes back to the whole discussion we had on pointers the week before. When working with these pointers, it's 2 components we're dealing with. We've got the actual variable that's sitting on the stack frame that is pointing, it contains an address that is pointing into the heap to the actual object. When we dispatch messages to the object, they're actually going to the object. It's not that we're calling messages on the guy that's on the stack. That's right, all these pointers are on the stack. Now, the pointers can also be in the objects as well. We'll get into it, but that gets a little complicated. Yes, all these pointers that we're dealing with on the stack. There you go. Awesomeness. Nina, what were you going to say or ask? Or did I miss a question? There's all sorts of stuff.
Yeah, that's the question that you missed.
I've seen examples of super Dealloc being called first and being called last. Is there a reason for doing one way or the other? Matthew, I always do last, and in some of Apple's documentation somewhere, I don't remember exactly where, they actually say call it last. Because look at it like this. It's your final cleanup. The deallocation begins in your object, which is an extension of their base object from the framework. Don't let them start trying to finalize everything first with you not having cleaned yours up. You're going to possibly run into unpredictable results. So you clean your stuff up first. Once you're happy with your cleanup, then you turn around and say, all right, super, do your thing, and you're done. You're completely finished then. Just don't forget to call it. So I would never, and I never have in the past, in any of the iPhone apps I've written, I've never called super Dealloc first. So anyways, that's what's going on there. Let's jump back over here into our code. And hopefully with that breakdown, that makes things a little bit more clear here. But then why down here I need to do this release on message? Because we know that message is only getting a release sent to it anytime we send a new NS string into it. So I send a new NS string into it. I was like, hey, let's make an NS string. We're going to call it hi. Send hi to set message. All right, so we got it. We set it up to retain count once. Now, if I don't go in here and reset a message, that guy's not going to get a release from me. And what have I done? I have said right here, I am going to claim ownership to it. So if somebody else releases him, I'm safe at knowing that I've caused the retain count to go up by 1. So if somebody else releases him, he should be released only because they know, well, you as the programmer know what you're doing, and you're releasing somewhere else because you had claimed ownership in another object somewhere. Okay. And then Warhammer says, like var initialization. Variable initialization. I'm trying to follow. Yep. to make sure it has no strange value at the start. Ooh, to make sure that it has to make sure we're not leaking memory. Because this, if I did not, I mean, that's awesome that you said that. If I don't release this guy and the retain count doesn't go by 1, but I have retained it, if I put a stake in it and said I'm claiming ownership, and I don't release it, when the application ends, we have a memory leak. So as your application's running, if we're creating an object and then we're killing that object, but that object has other objects that it's referencing inside that it claims ownership to, but it's not releasing them, what's going to happen to our memory over time? What's going to happen to the heap? It's going to get bigger. It's going to become bigger and bigger and bigger and bloat it more and more with objects that are just abandoned. Yes, it'll leak. And that's bad. And next week, I think I'll, if you guys don't mind, let me write one more cool thing in that I'd like to add into the class. Hope you guys don't mind. I like the idea of as inspiration hits. Because if I don't write it down, I'll forget. How about we spend a little bit of time next week looking at instruments and actually taking a look at profiling our code, just some simple profiling and physically seeing memory leaks. That'd be fun. Okay, so protocols and dictionaries and instruments, and we'll have more stuff to come. All right. So here is our very, very simple application or class that we've put together. At this point, going back to what Nelson was saying earlier when he was going back over the object-oriented programming paradigm, we've defined a template. Oh, Mandro's in here. That's right. Real quickly, let me just throw this in for those of you that may have come in late. I asked at the beginning if everyone was cool with me adding another week, because tonight I'm hitting everything that really needs to be hit. So if you're one of those people that get real mad because, oh, he's putting extra stuff in there, stomp, 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 that's cool. I've covered everything I said I would.
Oh, yeah,
but I'm gonna put another weekend because I want to go into some more advanced stuff that we can take advantage of in the iPhone development class. And I like the idea of simply being able to tell people in the iPhone class to go back and watch week number 5 of this class and see it, and so I don't have to like re-explain the whole thing in simplistic baby terms. Yay! Okay, so anyways, so if it makes you mad or if you can't make it, it's all good. Hi, Ashley. Glad to see you was able to join us tonight.
Ashley!
But if you're unable to make next Thursday night, not a problem. Again, I'll be recording the video, and I will put it up for you guys. All right, so we've got a class. Now we need to use it. But before we use it, now let's couple some actual lecture in with its usage, with the whole instantiation process. So let's jump back over here to my super sexy whiteboard. Yeah, you can tell Nelson's writing skills are definitely getting better as he's doing a lot more drawing, and mine are...
I can read that.
Mine are getting horrible.
No, I can read it.
Let me see where I want to put this. Nope. Bear with me. I'm going to have to put this on another screen because this will probably end up growing like a craziness. And I know I don't have to always bring that back up. Well, yeah, I do because I want to hide that out. So, sorry, I'm like correcting my own self. All right. So we've looked at defining classes. Now let's look at instantiating classes. Let's turn that template into an actual object. So there are, all right, this gets into, we're only going to be looking at 3, what the heck, I'll throw in 4. We're going to be looking at 3 4 approaches for instantiating objects. I was originally going to only show you guys 2, so you got to bear with me. I'm just kind of expanding the class on the fly. First, Alloc. Where did Alloc come from? Quick, tell me. You guys aren't quick enough. I don't care if there's a lag. You should already know. You should already be saying it, even if you are just now getting my words. Where did Alloc come from? I've gone over it twice. Thank you very much, Mr. Lewis. You get the cookie, sir. Jonathan, go outside and play. That doesn't count. So Alloc came from NSObject. Now, what kind of method was Alloc? You guys recall? I drew the little symbol. It was a class. Very good, Terry. So we've got Alloc here that is going to handle setting up, getting the memory for us, and the address pointing to that memory on our heap. So if we were to actually look at this on NSObject, we would see it as a class method, as Terry just said. Return type is ID. Ooh, something new. So there's our prototype. So this is going to, and what ID means is it's a special keyword that basically means some kind of object. It's just some kind of object. So all objects can be represented with ID. Now, Alloc is going to get that memory for us defined on the heap, but we still don't have our object initialized. And that is the next thing that we saw. Init. And what kind of method was initialize? MMO does? Look to Terry. Terry's the man. Terry is the man! It is an instanced.
The minus thing, right?
Yep, it's an instant method. With this being an instance method, the important thing to understand is, oh, wait a minute. That means I can override this. I can give my own functionality, like a constructor, from those of you that are from other languages. That's right. So again, it's going to be looking pretty much like the same with the exception of the symbol. Okay, these two guys are going to work in conjunction with one another to give us an initialized object from a class. So again, up on the stack, we have some variable. It's a pointer. Let's just say it's MyObj for my object. Down here in the heap, remember, that's that cool place you can go get margaritas, hang out with all of the awesome dynamically allocated objects. So down here on the heap, when we call Alloc, so let's go ahead and say we're going to make a MyObj. It's I love it. People get all freaked out with pointers, but in Objective-C, since like almost everything you're dealing with is a pointer, and you don't have to do lots of weird pointer stuff all the time like other languages, for those of you that are familiar with more advanced things that you can do with pointers, it's just annoying every now and then. You just got to kind of put in the symbol. Okay, I'm simplifying a little too much there. But anyways, so I'm going to give my identifier. And now what I want to do is come over here, and I want to actually create this guy. And so in order to truly instantiate, I need to first start out by making a call to a class level call to MyObj. Again, class level, I'm sending a message to, that is the worst J I have ever seen.
It was kind of like a J.
Yeah, exactly. So I'm calling Alloc. So that is the message I'm sending to MyObj. So we're sending a message, so we put it in these square brackets. And again, we're not doing it on our identifier. We're actually doing it on the type itself, which is class level. So this is our type. Even though it's a class, that is the type MyObj. Just like if we had made an NSString, we could say the type of that is an NSString object. It's an NSString. Now, I can nest these guys, which we will do. What this is going to give us back is going to be a pointer. I'm going to make the memory area look a little more interesting. Yeah. That was the memory that is set up that is actually needed to hold a MyObj in it. And we get something else from Alloc as well. Alloc doesn't only go through and get us the memory required, the footprint for that object to fit in, it also takes care of all of the initialization for us. Meaning it goes through and it zeroes everything out or sets everything to nil, depending on what it is. So this has all been cleaned. Blah, 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 blah. Then, so again, this that is coming back, we could actually take that information and just put it over right into MyObj, this guy right here, and then turn around to MyObj and call init on it. But I'm just going to, because you're going to see this all the time, I'm just going to do a nested call. And we talked about this last week as well. So here's our inner call. This happens first. And then this is going to return with a pointer to that object type, which needs one more I in there. And now we can call upon this guy's init for it to actually initialize. Okay? And I'm looking over at BuzzNet now for the first time in a few minutes. Init, not int. Yeah, I know. That was my bad. Sorry. And so now, after this execution is complete and we're on to our next line, we have a fully instantiated object. Now, let me point this out real quick. So let's pretend same thing, same thing. I could come over here. If I do not need to initialize any parameters on the object, or not, let me not say parameters, let me put it in a different way. If I do not need to initialize any data members of the object, I can simplify this right here by simply calling new. Meaning I can say, give me a new MyObj. And all this is doing right here is both of those two. This is like shorthand for doing that. Okay? Which puts the address in MyObj, Mr. Lewis asks. And Terry and Mr. Warhammer are both correct. Alloc. Alloc gets the space set up. It gets, which means obviously we have a memory location at that point because we know where the memory begins at for the object. It gets everything initialized to a default state, and then it returns the address back. And then it's on that address that we can then start calling methods and all, such as initialize, to initialize any parameters in it that need to be initialized. So what does init do? It's like a, for those of you from other languages, it's like a default constructor. So init is where you will initialize things that need to be initialized on a class when you instantiate it. And tonight we will be doing that. We'll be looking at designated initializers and just regular initializers. So just that's what it's for. So far, are we feeling pretty good with what we've seen? I'm trying to keep it real simple. I know the cool thing is I can jump in here and start blasting right into all this code with last week's example. because last week we didn't really break it all down. I just had you guys follow us, and then the class turned out to be 12 million hours long, and we couldn't go any longer because, like, we looped evolution, right? We had a evolution Stack Overflow, and dinosaurs started coming back around, so it just wasn't good. All right. Now, I said I was going to talk about 4 different means of getting an object back. And at this point, you've seen, well, 4 different means. Technically 3, because Alloc and Init go together. So this guy's one. What I was saying is I'm going to show you 4 different like keywords, and, well, 3 keywords in one approach. The other one is new. That's 2. And then the final one is going to be a factory method. A factory method is a method that's going to reside on a class. It's a class level method. You've seen how Alloc is class level. What's really cool about doing class level methods is, and again, you can think of these when a class is going to use a class level method to instantiate itself and hand it back. These are factory methods. They're in charge of constructing themselves, adjusting anything that needs to be adjusted, perhaps storing references to them in repositories, and giving it back to whoever requested the object be created from. So, an example, tonight I want us to get into collections, I had mentioned earlier, which was cool because, again, collections were not part of this class at all. We were going to talk about them in iPhone development, but then I told myself earlier last week that I was crazy for not wanting to get into them right away.
Crazy.
So we're going to do them now. So an NSArray is a collection. How many of you that are in BuzzNet right now have never heard of an array before? Never heard the term? That's the elevator music.
Oh.
And that was the symbol. Oh, funny sounding symbol. All right, so everybody's heard of an array. Fantastic. So basically, we have a collection of data here. And we'll talk about creating NS arrays and NS mutable arrays and things like that here in just a little bit. But what I want to do is take a look at just making a quick one using a factory method. I can come in here and say NS array identifier is going to be my array equals. Now, remember I just said that they were class level, so that means I need to talk directly to NSArray because I'm talking to the class now, and then I can use one of these factory methods that are available on the class array called array with objects. Ah, man, they're so verbose. And array with objects is going to take in arguments. So the argument that we're going to send into it, let's send in just a couple of things because well, hang on. Now I got more space. So let's go ahead and send it in some NS strings. I'm going to send it in JSON. What does this say once again? Quick, come on, give it to me, give it to me, give it to me. What does this @ symbol mean in this particular usage, in this case right here? Literal string, make it more specific, my good friend, and I'll smile really big. Okay, good, Terry, good. Now, what is it saying? It's preprocessor saying that this string is an NS string. That's correct. That's what I was looking for. That's very, very important to understand. So we're not dealing with just a regular C string. We are dealing with an NS. This is an actual object. I can call methods on this guy right here. It's pretty funny. So let me go ahead and undo that. So let's go ahead and put 2 more things in here. So @Nina.
Me.
And we can't leave Rowdy out, right? I mean, Rowdy's like, he's the one with the black goblet. Yeah. And I need to specify to this method that this is the only objects that I'm going to be adding in here. So I terminate it with nil. And then that ends off my message. And there you go. So NSArray is not a mutable array. So we'll be talking about immutable objects here tonight, just like NSStrings are not mutable. We have to use NSMutableStrings if we want to truly change the text content that's within that object on the heap. Same thing goes for an array. So an NSArray, this guy right here, is not mutable. But I've gone in here and I've defined this guy as having 1, 2, 3 elements in the array. And we'll talk more about arrays here in a bit, but the key thing to understand is I used a class level method available on NSArray to allocate and instantiate an NSArray populated with the following data and had that handed back to me in my array. So that's a factory level method. And we might play with those a little bit tonight. We'll see. So far, so good? Yes, good? I'll just talk ahead for you guys. That array is immutable. That is correct, Jonathan. You would have to, if you want that array to be mutable, then you need, no, it's not because of the nil. It's because of the type. The type that we're using is an NSArray. The type that we would use for a mutable one would be an NSMutableArray. Just like strings. NSString, not mutable. NSMutableString, mutable. And as Matthew just said, nil identifies the last item. Well, yeah, as the item being the item before. Nil is the terminator, basically. Okay. Why do you have to identify? That's how it's set up. You're always going to be using nil. Yep. As Mr. Lewis says, nil says, we're done now. Have a good day. All right, that is instantiating classes. So if I wanted to, using our little example and the awesome participation I get from Mandrill and those of you that feel like jumping in from time to time, I want to create this guy. What do I do? Help me out here. I want you guys involved. I now have a message dispatcher. Where do I need to go to create him? Nina? Yep. Nina. All right, Mr. Lewis, I like the way Mr. Lewis is thinking. He says, let's go back over to main. This is where the heart of our program is running.
That's right, because we were in, okay.
Because this is where,
main is
when we start our program, this is where program execution begins. It's our entry point into the application. Nothing's going to happen with this. This is just a template. This is like me grabbing a piece of paper right now and drawing the plans for a cool rocket ship. I'll tell you what, it'd be a mighty cool rocket ship, but we couldn't actually get in it and fly anywhere because we haven't built it yet. Of course, my rocket ship would have memory leaks and it would definitely crash, but that's not the point. So we do want to go back to main. So what's the first thing I need to do over here? Help me out here. Okay, Mandrill's all over it. So Mandrill's saying what we need to do is we need to start out by first declaring a variable that's going to be on our stack that is of type message dispatcher. And it's going to be a pointer, so it's going to be pointing to a message dispatcher that is going to be dynamically allocated and placed on the heap. So, but before that, we want to do one other thing. Thank you! Mr. MMO Dust is all over it. We need to make sure we import it because otherwise it's going to be like, what are you talking about? So we're going to say import, and now we can just use our double quotes around it because we're just looking for a header that is local, and we want to bring in the message dispatcher. And now that we brought the message dispatcher in, the next thing that we're going to do is, just as Mandrill said, first thing up, we need to go ahead and declare it. So message dispatcher, I'll call it my dispatcher. equals, and now we want to make a call, a class level call on message dispatcher.
Message.
And you guys know that came from the Alloc on NSObject. So let's use it. So we're going to say message dispatcher, Alloc. And then what we get back from that, we're going to make another call on that guy to initialize. Internet, very good, very good. No errors. We are now looking at an instantiated object. What do we need to do now? Anyone? Call our method. Put something into it.
You gotta.
What, Nina? Nina?
Oh my God! It's what's the word?
Oh, Mandro trying to get all sorts of fancy. Oh, look, yeah. Oh,
It's
look
like
at you.
okay, you have to.
We have to. All right. We have to think about memory for a minute.
You just said it earlier.
We have to think about memory. We rather need to retain this. Well, the funny thing is not really because we're in main, but I'm wanting people to think about, I want people to really start thinking about memory. And one of the rules that we're going to be talking about later is any time that you use an Alloc and an Init, you better be hanging on to it. You better be staking claim. So meaning you better retain it. So what we could do here is we could go ahead and just put this guy, register with the auto release pool, so that when we're done here with main, which means we're going to fall outside of our auto release pool, what's going to happen? Well, a release is going to get dispatched to all of the objects that are registered to it, meaning the retain count will drop down and be gone away, all that good stuff. So my dispatcher, auto release.
Auto release.
Now, if we wanted to, we could come up here and really? And do that. Okay? Now, if we run it, nothing blew up. Nice, clean looking line. Not a nice looking warning though, because we've just made a variable that we're not using. So now we need to use it, as you guys were already saying. And to use it, we need to, well, how does it work? We need to actually put a message on it. We need to send it a message to store some sort of information. So I'm gonna make a call. I'm gonna say my dispatcher. And then I'm gonna actually talk to a message. Set message.
Oh, and that's the NS string. Oh.
And now it's looking for us to send it an NS string, and I'm just going to send this a constant over. Hello world. And now we need to actually do something with it. So we need to. Oh, Mandrel's all over it once again. We need to call the what? I keep. Huh? What, Nina?
I know. I'm having a...
All right, Nina's dying.
So that's the method that you call,
this,
right?
We just...
Wait.
This is the method we just invoked. This is the message.
Okay.
This is the... And to do Objective-C talk, this is the message we just sent to this object.
Okay.
So we sent the message, set this message, and this is the argument that we sent over. Hello world. And so... my dispatcher said, oh, cool, man, let's just, well, actually, set message on my dispatcher said, cool, thanks, let's take this guy in and let's set some stuff up, and all right, it's having a good time. So next thing we want to do is we want to go ahead and dispatch that message.
And then, okay.
So dispatch message. We run it, we get hello world. Ta-da!
Dispatches the message. Okay.
And Terry says, can auto release be at the end of the code?
Yeah, like after you dispatch it.
Down here? I mean, you can register it at any point. We're still inside the thing, but that would kind of be bad form. You'd want to make sure that right after getting your hands on an object that you want to retain, you'd want to retain it. If you're in a method and you're returning an object back to somebody, you'd want to make sure you set it auto-release before you return it. And those get into some of the interesting rules of the reference counting memory management system, which we'll talk about here very shortly. So, pretty straightforward, really. I mean, for those of you that are really new to programming, it's just a matter of becoming comfortable with the syntax, following the syntax. And for those of you that are coming from other languages like C#, it's a matter of becoming comfortable with the funky, the funky square brackets and all that good stuff for messaging and all. Yes, I know. It is definitely the longest hello world in the world. But it does show the whole idea. Yep, and it comes from Smalltalk, which is funny, because Smalltalk's not Smalltalk at all.
Nope.
It's verbose. So let us go ahead at this point and take a break, because I think I've been going for, looks like, quite a while. And I need to discuss with Nina some of the Thomas picking up stuff here. So 10 minutes, stretch your legs, relax, and then we will pick back up. And welcome back from the break, everyone. All right, so what I want us to do now is to talk real quick about methods. I mean, we've seen them, and we've seen them, and we've seen them. Now let's just make sure we do the right thing. Ooh, wow, that's horrible looking. Let's go ahead and make ourselves a new layer. Hide this guy out.
For a second, I thought you were talking to me, and I was going to be really offended.
How? Like your drawing was horrible?
Oh, I'm drawing.
All right. So, make sure I'm zoomed in as well. There we go. Oh, for you guys that already know this stuff, as I've lectured a million times in the past in this particular class, I gotta go over this stuff. This is the basic beginner stuff. Okay, defining methods. First thing, as you guys already know, you need to be aware of the fact that there are two different kinds. You have instant methods, like instant potatoes. Getting hungry again. And we have class methods. You guys have also seen that we designate those with the minus and the plus characters. Okay? So the syntax is very straightforward. Except now we're going to look a little bit closer, though, at the parameters, because this is so important. And what is actually considered the making up the method signature. So first thing, we're going to start out by designating it as an instance or a class method. Then we have to specify our return type. And then from there, we give it our method name, or I'll just put identifier. Now, this right here is valid. I could put a terminator, and that's a terminator. And this right here is a prototype for a method that we could then go and implement over in an implementation file. But we need to start talking about parameters. So let's go ahead and just take those two dots out. So if we were going to send arguments in, we would put the colon, the type, generally, almost always a pointer, the identifier, I'll just say ident. Now, if we were to send in a second argument, here is how we would specify the next incoming parameter or incoming argument, how you specify the parameter for it. Wow, that was a mouthful. And another colon, type, and most likely a pointer, identifier. And then we could just continue on and on with our, there is a space. I just saw a question about space. We don't have to have spaces in there. The only space that we have to have is going to be between our parameter here and then our next specifier, which is part of the actual name. So the method signature is actually, in this case, it would be identifier, R, that is an R. It's like, why does that look weird? Colon and another. Okay, so that is our signature, though that's not very relevant. That's just for those of you that understand what method signatures are from other languages. So this is prototyping it out in the header file, and then of course we need to turn around in the implementation file and actually implement it. And oh, there is another colon in here at the end. Thank you very much for catching that. Yes, because we are dealing with parameters. Thank you, thank you. So now let's go ahead and take a look at the anatomy real quick. I've been mentioning this, and I said I was going to be doing it quite a bit tonight, so it just kind of seeps in, just like the ownership thing. And the way that this is done, it's receiver, and then our message. So when sending a message to an object, we specify which object will be the receiver of the message, and then we send our message. So, I mean, it's really straightforward. I mean, that's pretty much it. We've already seen through the use of Alloc and Init that we can embed messages. So if we had something like, say, I've been using MyObj a lot. So if we said MyObj, that's a J, and then I had, let's just say that I had a method on it called meth1. I could call that, and then I could call another method. So there we are doing method nesting. Of course, our evaluation starts from the inside, working our way out. So very straightforward. Now, objects can also call methods on themselves. So this is the first time that we really get to add something new into our arsenal, and that is the keyword self. Self is a way of pointing to ourselves. It's a way of identifying ourselves as an individual instance on who we actually are. So I could say self and call, you know, meth1. And this would be calling the method meth1 on my own instance. So it would be my own behaviors meth1 that I would be calling. And this is going to become very important here in just a couple of minutes, because we're going to be talking about class initializers. Is self method the only way to call your own methods? Yes. So now what I want to do is I mean, we've seen methods quite a bit. I mean, the big thing to keep in mind that trips people up, I mean, it tripped me up as well. I've been coding in C# for a long time, and then way back in the day, C and C++, and then moving over into Objective-C for the first time, because, you know, I wanted to get in there and start making iPhone apps. Started trying to get my head wrapped around the language, and, you know, I thought methods looked really odd, but the moment I started dealing with parameters for methods, then it was like, what the heck? You're going to find some extremely verbose methods out there in the Foundation framework. You guys have already seen one of them when we were taking and converting an NS string object over to a C string with the UTF-8 encoding. That was mighty insane, and that's pretty common. You'll find that the language is very verbose, and they're wanting, they being Apple, they're wanting the code to read in a very user-friendly way. That's why the method should just, you know, read along the lines of, like, if we were going to set, if we had a method for setting an X and a Y, we could say set position X colon, and then take in the parameter, or specify the parameter for it, and then move over to the next and say, and position Y, and then take in the argument, or specify the parameter for the argument in which we would be taking in. So it gets very verbose quickly, especially if you end up with a method signature that has, you know, 3 or 4 different parameters that you have to send into it. So we're going to be making use of these guys. I'm not wanting to spend a lot of time on this because we're going to continue playing with them all throughout the night tonight. What I do want to do now is jump over into class initializers. So now that we have a feeling of how to use methods, let's talk about how we can override methods. And where did my pen go? There it is. It fell. So I think most of you in this class are comfortable with the concept of a constructor from other programming languages. The idea of a constructor, for those of you that don't know, is being able to have a function set up, or in this case, a method set up that will allow you to do some custom initialization when an object is instantiated. So if I wanted to instantiate an object, and when that object was instantiated, I need it to say, let's say I had an array that was going to store information, and I needed to allocate and initialize that array. I could take care of that in its initializer. So those of you that are comfortable with thinking constructor, start thinking initializer, because that's what we're going to be doing here. Now, you guys have seen that the instance method we get from NSObject is called Init, and Init is going to, basically it looks like this. So for us to go in there and define our own initializer, if we were going to create one that did not take in any arguments whatsoever, this is our signature that we're going to be using right here. But there are some interesting things that you need to keep in mind when you are creating your own initializer. So let's go ahead and look at that. So in the implementation file, it would look just like I was creating a regular method implementation. Of course, it's not prototyped because, thanks to NSObject, we are already aware of it because we've inherited it. The first thing I need to do is I need to let anybody above me, I need to let my base class handle initializing itself and making sure that everything went nice and kosher with it. Now, you guys saw that we can talk to self and send it a message, if we need it to talk to, and this was mentioned earlier, our base class, we would talk to super. We did that with the Dealloc by talking to Deallocs, to the super's Dealloc. So in this case, instead of doing it inverted, if you recall with Dealloc, it's recommended, well actually where I read it was just outright said, make sure that you call the super's Dealloc last once you're finished with your cleanup. Here in initialization, you want to call the super's initialization first, because we need for it to be able to handle all of its regular initialization and to make sure that it hands back to you a proper object. Because what if something went wrong above and you ended up getting nil back? Well, you wouldn't have wanted to have gone in there and start trying to set up stuff yourself without having gotten the object fully properly initialized. The NSObject has to get initialized. So this is the first thing that you need to keep in mind. It's very important, is that in the implementation of your own init, first thing you're going to do, and people write this in different ways, you can handle writing it however you want as long as you understand the logic here, but I'm going to come in here and I'm going to say self. Remember, this is an instanced method. Since it is, I'm now talking to myself. If self is equal to, and now I'm going to do a message to the base class by saying super init. So if this guy properly initializes, what are we going to get back here? We're going to get back a properly initialized base and above, because if there was a base above that class and a base above that class, it should chain its way all the way back up and then start working its way down from NSObject, with each class that extends the previous getting properly initialized. And coming back to self, we should get our, it's going to sound weird, we should get ourselves properly initialized. If something went wrong further up the chain, coming back would get nil. So in this case right here, I'm just outright doing an if self equals. So I'm doing an assignment. If I get nil back, we're just going to jump over this. If I actually, because nil's nothing. But if I get something back that's not nil, then I'm going to do my code in here. And this is where I'll do my member initialization. So if I need it to initialize whatever it may be, instance variables, arrays, things like that. Wanted to set things up, etc. So the last thing that needs to be done is we need to make sure we return self. And there you go. Because if you don't return self back, well, number one, the compiler is not going to think highly of you because you said, you were planning on, it's just going to complain that you were planning on returning something back. But more importantly, you just broke the whole mechanic of the idea of initializing an object and getting an initialized object back. So, and remember, what is ID? ID is just it's some object, it's some kind of object. Yeah, self's a pointer. Now, to be completely honest, I've never read into how they go about the true mechanics of it under the hood. But if it wasn't, I got to be careful here because you can actually get into a situation where you want to check this because you could get something other than self back, and that might make you go, whoa, what? How's that possible? Other than nil, but something else that's other than self. But when you start working with class clusters and with core data, you can get into situations that you really want to make sure that you're checking self, making sure that's what we got back. But that's a very rare set of cases, and nothing you guys are going to be seeing in here, and I guarantee you nothing you're going to be seeing in the iPhone classes for a while. If we have enough interest, we'll keep them going past the 101 class. But here we're just wanting to make sure that what we're looking at is, we're still looking at ourselves, and the base above us has been initialized by the time we get back to this point. So remember, it's climbed all the way to the top and then worked its way all the way back down from NSObject, initializing each one. So we end it all off with simply returning self back. If something ended up getting screwed up, then we would be returning back nil. Confusion time. Is that equals or equals equals? In this case, it is a single equals. I'm actually doing an assignment operator. Like I'm kind of shortcutting this. So instead of doing an equality test, there's no reason to. I always shorten up my initializers. Because the bottom line is, it's not returning true or false. It's returning an object or it's returning nil, nothing. And said, no, it's not a Boolean here. So nil, just view nil like 0. It's false. I mean, that is that straightforward. Let's keep the language nice and simple. But it's, just like if we did an assignment like x equals 10, well, what would x be? It would be true. Yep, 0 or anything else, exactly. So as Warhammer just said, an assignment just like x equals 10, yep, we're getting double the bang for our buck. We're doing an assignment, and if the assignment is something other than 0, or to say it properly, if it's something other than nil, then we need to do what's in here. Otherwise, we're just going to skip over here and return self, whatever was sent back. If, change that around. You can say if assignment, but if expression equals, or if expression is checking true, false. Always. But again, looking at what we're dealing with self, we're dealing with these objects. And if something gets boinked up, nil is what we'll get back. But an if statement at the end of the day always boils down to yes or no, or true or false. It's rather something or nothing. If we get nothing back, it's 0, it's false. Okay? This is the structure that I would recommend you guys follow for. It's very simple, it's very straightforward, it's very easy to use. But now what I want to do is take it one step further and talk about what happens if we wanted to have multiple initializers. Let's say, for instance, we had a person class, and the person class had a name and an age. And if we wanted to instantiate, if we wanted to give the option of instantiating that class with an assigned name and age, then we would want to do something a little different than just init like this, because we're not sending in any arguments. We can't send in any arguments because init doesn't take any arguments. So now we would need to prototype out over in the header file what our init with is going to look like. And MMODust, I just looked over at BuzzNet, is right. Init with stuff. So, oh man, I'm running out of space already. Ah, a little bit over here. Sweet. So if I wanted to say instance methods, I'm going to return an ID, and it's going to be init with name. So an NS string pointer, and we'll just say that it's the new name coming in, and age. And we'll say that this is a NS integer. And I'm running out of, do I have any more right there? Nope. And then so just, this is going to wrap around a little bit. So NS integer, and then we'll say new age. Yeah, new age. Okay, so anyways, we would need to prototype this out. Then we would need to turn around in our implementation file, and we would need to implement this. Oh, gosh, how are we going to go about implementing it? We're going to do the exact same thing that we already took a look at. We're just going to say if self equals, wow, super init, unless you're deriving from a class that's not NSObject. Let's say you're deriving from a class that you need to pass up the new name and age to, then you'd pass it up here. But we're just going to say that we're extending just NSObject right now. So self equals, we're going to call super init, and then with what we get back, now we could just come in here and say name, let's just say that's our data member, equals new name, age, as Warhammer says, equals new age. Like such. Of course, we'll terminate and all that good stuff. And this is going to allow me to talk about one other interesting thing, which is our designated initializers. Let me go ahead and move this down a little bit. So a designated initializer. Think of that as, it's kind of the, it's generally the initializer with the most parameters. It's kind of the heart initializer for the class. Because if this class is designed to be used in such a way that you're expecting to give it a name and an age, well, what happens if somebody comes in here and calls on init? So what we can do is we can just start chaining these together like such. I don't need to prototype this out, of course, because I'm just going to be using init, which is already available to us. And how much space do I have? Okay, I think I got it. Good. So now it's going to be if, now check this out, self equals, and who am I going to call? I could now make a call to the other init and call on init with age, or a name, sorry, hang on. Colon John Doe and age 0. And can barely squeeze stuff in. So this is, again, is just going to basically, we're just going to call ourselves, which is then going to come in here and call supers init. And then from there, we get back an initialized object with anything higher up initialized. And then we can take care of initializing ourselves. And since we don't know who this poor dude was, we'll just call him John Doe with an age of 0. I don't know. Making up some stuff, okay? So what I want you guys to do, are you still there? Nelly. Are you still there? Hello. I'm just making sure you're...
Hello.
Nelson.
Can you hear
I can
me?
hear you.
Oh, okay, I can hear you.
Why'd you just keep saying hello, hello, hello?
Sorry, I was distracted.
Oh, I see. Let me pull you back into the class if you don't mind. And actually, think real hard about this line. Don't write it the way I'm writing it. Think about what's already in place for you with the way that we're chaining this. I mean, we already know if we're getting nil back or not, right? So all we need to do is make sure we call ourselves, sending this stuff in, and then returning self. I'm surprised nobody said anything. If something got bonked along the ways, we already have nil being assigned because we've already made sure that our designated initializer took care of making sure that supers init was indeed called. So what I want you guys to do at this point is to go ahead and create, so now it's time to actually do something. I want you guys to create just a very simple Objective-C application using Foundation, just a regular command line tool like we've been doing. And I want you guys to create a person class and set up the initializer, make use of it, and take your, let's see, how do we want to do this? Do 2 submissions. Now you could just put it all into one. You can copy and paste your implementation, your header file, and then copy and paste your implementation, and then copy and paste your main, and put it all into the code button that Nelson is about to now activate over in BuzzNet. So Nelson, if you could set up a participate and just call it simple init. Is good enough. And what I'm going to do is pause the video. So for those of you that are at home watching this later, try it. Pause the video yourself because it's about to instantly snap right back up for you guys, and see if you can put together a very simple example based off what I've been talking about. I've already gone over everything that you need to do. The only thing is go over and actually create the object in main. Make the object. Set it up. All right, and so with that, I'll pause the video. Okay, guys, we're now back. So I think I failed horribly in explaining, and I'm awfully sorry if I did. Let's jump over real quick into Xcode, and let's take a look at what I was looking for. What was the first thing that I wanted you guys to do? So help me out. Let's get some class participation going here. First thing was make an object. But before, Jonathan, we can make an object, we must do what? We talked about it so much earlier. Before making an object, we must have a class. Create a file, right? We must have a class in which we can instantiate an object. So I had asked you guys to make a person class. So I'm just going to go ahead and hit Command N, and I'm going to do an Objective-C class. Next, the class is going to be, I'll just call it person, and it'll simply go right there. Good enough. So let's jump over here to the header file, and this is the first place that I want to start working. We saw earlier when we took a look at the syntax for a class that the first thing inside of interface that we needed to do was to set up a block in which we could define our what? Anyone? We need to define our instance variables. Okay, so these are going to be instance variables. These are the data members that give state to our objects. So what do we want? NSstring for name. And I'm going to use an I'll do an unsigned integer for age, because you really shouldn't have like a negative age. Well, at least I wouldn't think so. But if you did NS integer, that's fine. Okay, so that's the first thing I want. Now the second thing that I wanted to do, I'm not even going to worry about, remember we also took a look at in the syntax at properties, but we're going to be talking about properties in more detail later. What I want to do now is set up a custom initializer that the system is not going to know about. Meaning right now, since we're inheriting from object, we already know about init. So over in the implementation file, we could just start implementing our own init, basically overriding writing the other one. So here what I'm going to do is I'm going to go ahead and prototype out this method. It's an instanced method. It's going to return ID. And then we're going to do init with name. And what I'm going to do with init with name is, I just happened to look over Warhammer. Said his age is not a pointer. This is a case where age, we're using a type that is a value type. An NS unsigned integer is a value type. So init with name. And now we're going to go ahead and come in here and tell it that we're expecting NSstring and a new name and age. So far, so good. I mean, up to this point, just staying focused only on what I'm doing. Is there any questions with what I've done so far? Got that. Okay, fantastic. All right. If anyone else has any confusion, I'll move on, but just go ahead and throw it over there in BuzzNet or the questions panel. I'm watching both. So what I'm going to do now, we've got it prototyped out, is I'm going to go ahead and copy this guy, save out my header file, jump over to my implementation of person, and then inside here, we need to make sure that we implement it. So, what do I do? Help me out, guys. Some of you guys were complaining that you couldn't type it because you might be on Windows. Well, you can at least start helping me out. I wrote all of this fantastic stuff on the board for you guys and drew little arrows and pointers and, well, okay, so MMO does says, let's do if, and then he's saying self equals, and then he's calling super init, so that we get everything initialized properly. And I like jumping down here just to make sure that nothing gets forgotten. I'm going to return self. Okay, and then, oh, very cool, Terry. So looking over there, so now Terry says, all right, well, what if we come in here and we say take name and set that equal to new name and take age and set that over to, I put age, but let me change that to new age. Do. No, I don't care for that. I don't need a snapshot. Okay. So, looking over back at BuzzNet, good and good. So now if I was to come in here and let me give myself one more property, one more method. If I come back up here to person, void, and I'll do who are you? Who are you? Let's jump back over to person. And then from inside here, let's just do an NSlog. And then we'll just say name is, and we'll just use the description property to specify out what's going to be in the string. So that's not a Q, me and my great typing. And my name is blah, 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 and age is, what is it, a long decimal? And so we want to put in our name and our age. Line 18 has an error on the left side of AYE. AYE. Where you at? As in yes, LOL. Where did I misspell yes at? Give me a line number to look at. New age, line 18. Thank you. Aha. Awesome. Thank you very much, sir. Okay, so age is equal to new age, name's equal to new name. Is everything good here? Do we have any problems with this? Is this how it should look? Do I need to just jump over and use it now? Looks fine. Okay. But you need to make a person. All right, so what do I need to do? Yes, I'll be glad to show you the header file again. First you get a loving couple. All right, well, that's a pretty nice start. A little bit of wine. Then it doesn't have to be a loving couple. It'll still work. Because NSU, integer, is not an object. It is a value type. Okay, so MMO Dust is saying, are you good, Warhammer, with the header file? Okay for me to go ahead and switch over to main? Just a minute. Okay, pausing for 1 second. And I shall pause video. Okay, so next thing that I was told, let me go ahead and make sure that implementation file is saved. We need to jump up here to main. And inside main, I'll just jump down a little bit. And MMO Dust said, we need to make a person. But the problem with making a person is what? We need to make sure that we import our header file. So we're going to do a pound import. And we need to bring in person.h. But you guys all knew that. And so now we're going to, we'll call this person Nelson. And we'll say that Nelson is equal to, and now what I was given over there was we want to do a person, Alloc. And then we want to do an init, how nice is that, with name. So let's just tab on over and say at Nelson. And age is, you're 21, right, Nelson? I wish. Okay. Okay, so looking back over at BuzzNet, yeah, I couldn't get the printf to work for an integer, so I just said string. Well, plus I forgot my ID with the init with part in the header file. Ah, gotcha. Okay, so now I should be able to do a call to Nelson, right? Something like, who are you? And then I need to do what? No one? And I'm still not saying that the code is perfect. I've just been following your instructions for the most part, other than adding some of my own stuff in here and there. So I just ran the application. Upon initialization and running, you can see that down here at the bottom it is giving me name is Nelson and age is 21. Yet we released it because it's been allocated. I wanted to make sure that it got deallocated, which brings up a very interesting point. If we were to jump back over into person, better yet, if I jump into the person header file on line 13, I've got this NS string. What happens to NS string? What if somebody else did a release? And that's right, MMO Dust. In this case, we released it because we allocated it. It was not an automatic, it was not an auto-release item unless we register it with the auto-release pool, like we talked about last week. So we went ahead and relinquished it. But my question is, what happens to this NS string object? What if we ended up passing this person that we instantiate back over here in main? What if we had some other class that we instantiated that we then could pass people to, like let's say a classroom or something. So we enrolled a person in a class. And then let's say that over in that enrollment process, they performed a release on the person. What's going to end up happening? We haven't declared ownership back here in person, did we? And Jonathan's having a hard time getting his to compile. Okay, so Jonathan, if you won't, just do a submission over into BuzzNet with the code with problems. New errors, yeah, I need to see the code. So we don't have a Dealloc right now. So we need to make sure that we claim our actual memory. We need to stake claim to it. So we're coming down here, and we get this guy in, and we need to basically say we're going to take new name and retain it. Now this is an initializer, so we don't need to go and release at the moment. Okay, give me 1 second, Jonathan. So let's hold on to that. But what we do need to make sure that we do is we need to come in here, get and we need to make sure that we release this. Running it again. Same output. Nothing's been over-released, but it's been properly released now. And when we release our person back over here, once we release him, he's not been registered with the auto-release pool. This is going to, because our object comes into existence with a release or a retain count of 1 after we allocate it. So this is going to drop its retain count down to 0. We need to make sure that we hang on to it here, and then we properly dispose of what we've claimed ownership for here. And you might be thinking to yourself, well, this is just such a simple setup. Why even worry about that? Because it worked fine a second ago. Remember, I'm given a very simple task for you guys to try to work your way through. But what happens the moment we start having other objects involved and we begin passing this person around and somebody over-releases? We're going to end up with a crash as soon as we go back to some other object that then tries to perform some sort of message to the person, because the person will no longer exist. It'll be invalid memory, garbage, and we'll get a crash. So since person could last technically for a while, outside the scope of just this very simple example, this is a case where we would want to make sure that we actually retained this person by bumping its retain count up by 1, and then making sure we properly release it when we're done. Okay? So now let's try something else. So now what happens if I just do a regular release, regular init on person? How do I do it? You guys walk me through it. Tell me what to do. I want to override init. I'll get you started. Is that looking pretty good so far? So we know that at the end of the day, we're going to be returning self, most likely. What if we just treated this like a pass-through? What if I just tried a call straight to myself, and I'm going to do init with name, and give this a constant literal NSString object of John Doe with age of 0, and terminate. We've already got, this is our designated initializer. This is the heart of the initialization process. This is us simply overriding init to provide some default arguments for our initializer, so that we do indeed get our name and age initialized with something. So we can now count on this being a rock-solid class, and we will have those things initialized. So if you think about this, by calling myself init with name, so coming down to init with name, well, the first thing I'm going to do in here is I'm going to call supers init. So there we go. We're now going all the way back up to the top, and we're properly initializing, coming back down the chain, ending up with rather an initialized self or nil. If things did get properly initialized, then we can go ahead and hang on to our retain. Because otherwise, remember, if it's nil and we return nil back to ourself, well, what's going to be happening down here with Dealloc? Well, nil, nothing. There won't be anything to call. Something got screwed up higher up. So I'll go ahead and do a retain, because now I know we've got ourselves back and we're good. And then I'll simply set up my two guys. I'll return myself back to my caller, or to the sender of the message, which is back to here, and that's what I'll return back. So, I guess we could go over here real quick and just do a quick Alloc and init. Don't be a pain like that. It's trying to autocomplete stuff for me. Aren't you so helpful? You can see now after building it and running it, the name's John Doe and the age is 0. Oh yeah. And looking over Rowdy, saying the app code is kicking me off, giving me an error. Then he says, ah. I take it the ah is you see what the error was maybe? So I'm going to go ahead and hit pause for just a second. Okay, we're now back from that interesting talk with our students. And so at this point, we're now 4 hours of recorded video in, and we've been going on for, what, about 5.5 hours. So we're going to go ahead and bring tonight's class to a close. For those of you that are watching this video at a later point in time, please make sure that before proceeding on to the next video, if it is already created, please make sure that you have a clear understanding from everything that I went over tonight of how to go about defining custom classes using both a header and implementation file. Also, make sure you have a good understanding of how to create custom initializers. Very important. Make sure you understand how to do that, both with and without parameters. So that is very important. And then next week we will pick back up. Now I've already talked about what properties were, but we're going to be looking at those in some pretty strong detail next week. And then from there, we're going to be designing out our first, well, we're also going to be looking at data collections with NSArrays, NSmutable arrays. We're going to be looking at dictionaries. And then I want us to take a look at putting a lot of this, everything actually, that we've looked at over the past 4 weeks all together in a larger program that we're all going to sit here and design and put together and see all of the interesting memory quirks that are going to pop up at the least expected moments. It's fun stuff. So anyways, next week should be a really cool class. I hope that you guys are able to join me for it. And we'll be kicking off at 6 o'clock Central Time, and I'll be talking with Nelson again about he's got to give me more than 3 minutes before the start of class with him wrapping up the Android class, because I've got to have the time. But for those of you that were able to stick it out all the way until right now, thank you guys. I do appreciate it. Even if you are sound asleep right now in bed and you just have my voice in the background, it's still cool. How'd you know I was talking to you, Rowdy? I'm just playing. I know you're tired. So guys, thanks a lot, and keep an eye over on the lounge or in the live classes calendar. I'll make sure that we get the homework link put up in there, and then you guys will be able to exercise what you have learned tonight. So until next week, everybody take care. Again, I said this off camera. Let me say it on camera now. If you guys get yourself stuck in a situation, you're getting an error, you have absolutely no clue what's going on and why, please send me an email, and that is at busbyj, B-U-S-B-Y-J, at 3dbuzz.com. So again, busbyj at 3dbuzz.com, and give me the subject something like Objective-C, need help, and I will be more than happy to help you out with whatever problem you have run into. I don't want anyone stuck. All right, guys, we'll see you next Thursday. Have a good one. Goodbye, everyone.
Goodbye.